Good morning, everyone. Welcome to the Circular Innovation Forum. I would like to welcome you on behalf of the Canadian Materials Circular Economy Syndicate, who is our host today. This event is also supported by Circular Economy Leadership Canada. My name is Andrea Hans. I'm the Associate Director of Strategic Initiatives and Development in the Research and Innovation Department at Lambton College, and I will be your MC for today's event. We're very excited about the Circular Innovation Forum. This event's dedicated to exploring innovative approaches to circular economy practices across sectors in Canada. Today's event will emphasize and spotlight collaborations between Canadian colleges, industry leaders, and policy makers, highlighting how critical these partnerships are to advancing circular economy goals. I would like to provide a land acknowledgement. As we gather here virtually, we recognize that we are on the traditional territories of many Indigenous nations across Turtle Island, now known as Canada. We acknowledge the land that we are on, where we learn, work, and live as the ancestral lands of the Indigenous peoples, including the First Nations, Métis, and Inuit. I specifically acknowledge that Lambton College is located on the beautiful homeland that is the traditional territory of the Ojibwe, Potawatomi, and Odawa nations. These three nations make up the traditional Three Fires Confederacy. Let us reflect on our commitment to reconciliation and consider how we can support Indigenous communities and uphold their inherent rights, honoring their cultures, histories, and contributions. Thank you for joining us in this acknowledgement. Today's event will be made up of three panels. Our first panel is focused on the Canadian Materials Circular Economy Syndicate. Dr. Steve Riom will be the moderator, and he holds a PhD in chemical engineering from the University of British Columbia, and has over 20 years experience in circular economy fields, including biofuel development and sustainable innovations. As the Director of Applied Research and Innovation at Lambton College, he oversees the research initiatives driving academic and industry advancements. Stephen also serves on multiple boards where he contributes his expertise and connections to support circular economy growth. Steve will guide us through this first session of today and introduce the other presenters.
Thank you, Andrea. So I will just share my screen here. Okay, so yes, today I'm going to give an overview of the Canadian Materials Circular Economy Syndicate and introduce Lambton's kind of part in it. So without further ado, we'll get started on kind of the overview and the part that Lambton plays, and then we'll allow the other members to introduce their respective colleges and or organizations and the role that they play. So thank you. So Lambton College, we like to consider ourselves an economic development engine. We believe that economic prosperity depends on industry attraction, economic diversification, entrepreneurship, and local industry initiatives. So we contribute to this through partnership development, access to R&D, access to skilled people and training, and promotion. So we believe that these are the key pillars to drive economic prosperity. And research and innovation is a huge part of that. So as a research college, we believe that our goal is to push this forward. So some of our abilities here at Lambton. So some technical areas of research: we do polymeric materials, biomaterials, nano-based materials, recyclable materials, material property and application testing, and then a big one is scale up and optimization of lab scale processes. And then we also offer services that companies cannot find elsewhere. So these would be, for example, contract-based projects, engineering consulting, training is a big one as we are a college, support and access for funding for collaborative research, technology transfer and commercialization services, and access to highly trained experts and state-of-the-art equipment. So our goal is really to kind of act as a kind of laboratory for different companies so that they can, advance their commercialization goals. And we do this through these main areas related to the Canadian Circular Economy, Canadian Material Circular Economy Syndicate. So just some of our related expertise and labs. We have our material processing lab, which does all the material processing and formulation, that kind of stuff. We have the material research analyzer lab, which does the high-tech, analyzing, with the HPLC, the XRD, the GCMS, FTIR, UV-Vis. And then we also have a material testing lab. So that's where we, about the formulations of the materials developed, that's where we make sure that they're actually meeting the, the structural and thermal and other properties that are necessary in, in the testing and in the development. So the main area that we work with for the Canadian Material Circular Economy Syndicate is the Center for Industrial Material Development. As I said earlier, we have the technical areas of research. The Center for Industrial Material Development is a regional hub for industrial materials and biomaterial development projects. This started as, in our material processing lab. It was one of our very first labs at the college and has really grown from, industry need and the support of the college. So this is one of our first ones, and we've really grown it into something special through the years and allowed it to, work with many different companies to build, test, formulate, and develop new materials. So, happy that we were able to, add this to the Canadian Material Circular Economy Syndicate. So the actual Canadian Material Circular Economy Syndicate, how it got started? It was through an NSERC grant. It was called an ARTP application. And the definition of this is, colleges will undertake a set of applied research projects of varying sizes and durations targeted at providing innovative solutions to business challenges. So basically what we do at the college. The grant application should identify strengths and available resources at the colleges to address one or more research themes of critical interest to the college or regional and national business partners. So again, we chose, we got together the 4 colleges with complementary abilities and unique specialities that make the network very effective. The reason the partners were chosen was based on a shared kind of goal or ability, but then complementary. So, not everyone does, formulations or not everyone does, thermosets or thermoplastics or composites and stuff like that. So it's, varying levels of material development in the circular economy. So now the actual partners. So we have Lambda College, George Brown College, St. Clair College, and Cégep de Saint Jerome. So with these 4 colleges, we have quite the expertise in material development, everything from composites to biomaterials to even, metallic-based, material development as well. So this really kind of encompasses, a lot of different materials, and the main goal of this being the circular economy. So the rationale for forming the Canadian Material Circular Economy Syndicate is Canada is a leader in material production. However, this is mostly low-value petroleum-based materials right now. This is exported and then value added, leaving Canada out of the value chain. So there's a significant need for value addition in Canada and a more sustainable material industry. There has been a major shift in Canada from larger companies in this area to smaller ones. And this makes research and development support essential, as these smaller companies might not have the capabilities in terms of research, innovation, development that a large company would have. So the challenge for the college is taking the research and filling the gap of applied research in materials commercialization. So making sure that we can support these companies where they need it most. The goal of the CMCES is to create a nationally advanced materials innovation network dedicated to commercializing value-added technologies, create jobs and attract investment, provide resources to SMEs and speed economic recovery, and to support Canada as a leading country in materials and circular economy. So the focus of the CMCES is nanomaterials, sustainable material production, advanced injection molding, advanced 3D printing development, advanced polymer and composite development, and circular economy and recycling. So about the projects, so about the operations, the way we work is projects will run either individually, so a college will have a single project, or in cooperation with two or more colleges, depending on the level of cooperation and collaboration and the needs of the project. So if a project needs the abilities of two different colleges or three different colleges, great. That's why we set up the network. So each college will be responsible in the development operation of the project, or the lead college will be responsible for it if it is a group of colleges. Part of the funding is set aside for a management team. So this is managing funding, managing the project details, hiring, stuff like that. And then each college must serve at least 5 projects per year for the ARTP grant. And the company contribution is a 1-to-1 with cash and in kind. We put 20% cash, and this is open to adjustment in special circumstances, depending on the level of the company, what is required, and how big the project is. So this can be open. So some project examples that we have run at Lambton College. This is not an exhaustive list, but these are just some of the projects and the companies that we have worked with. So you can see here we have, recycled materials, investigate different properties of flexible packaging, new formulation development, high temperature carbon applications for aerospace industry, water treatment, even development of materials for water treatment, bio-based materials, and even advanced materials. So integrating, tracking apps or into recycled materials. So advanced formulation material production, and along with electronics integration. So it really does span kind of the wide range of material development with a focus on the circular economy. So every one of these projects does have a focus on the circular economy, either uses a bio-based material, a recycled material, or is intended to be a long-term use material that's not going to just be a one-time use. So now into the future. So the future goals are expand into areas expand the funding basically to keep the network going, increase the collaborative projects, obviously, and to potentially increase the partner colleges. So, we want to grow the network so that it can help more and more companies. So that's, kind of the future goals, and really just to keep this going, keep the good work that it's been doing, and to ensure that it is sustainable in the long term. Okay, and that is the end of my presentation. So I will stop sharing for now, and I will introduce the next speaker. So the next speaker is Arbab Khan. He is from George Brown. So Arbab leverages over 13 years of experience in project management, research, and business development as the manager of business development at George Brown College. He holds a Bachelor of Technology in Civil Engineering and postgraduate certifications in construction management and BIM management. Arbab is instrumental in cultivating partnerships between academia and industry, steering technology adoption and product development across sectors through his leadership at the Advanced Manufacturing and Prototyping Labs at George Brown, or AMP Labs. So the AMP Labs at George Brown provide cutting-edge research and prototyping services, including product design, advanced manufacturing, and prototype fabrication. The lab excels in offering expertise in process optimization, PLC programming, PCB design, rapid prototyping, and embedded software development. By integrating AI and technology into everyday manufacturing processes, AMP Labs propel innovation and tackle real-world technology challenges. So, Arbab, I will leave it to you to continue the presentations.
Thank you, Steve. Can you confirm if you can see my screen?
Yes, we can.
Okay, fabulous. Thank you, Steve, and the Lambton team for organizing such a great event and for leading the CMCES. Hello, everyone. My name is Arbab. I am representing George Brown College today, and specifically the Advanced Manufacturing and Prototyping Labs. Today, we'll talk about our focus, our projects, which have a focus on circular economy, and we bring a different flavor to the to CMCES, and you will see that through some of our projects examples that we talked through. Just a quick agenda. We'll talk briefly about the college's Office of Research and Innovation. Then we'll touch upon the program areas. Then we'll dive a bit deeper into the Advanced Manufacturing and Prototyping Labs. And then we'll wrap up with a few project examples that will kind of help you understand the capabilities that George Brown brings to the table. So about George Brown is a large public post-secondary institution that hosts around 28,000 full-time students and over 53,000 continuing education registrants. And this we are located in downtown Toronto, and which enables us to kind of touch upon the ecosystem, which is very rapidly expanding. Briefly about Office of Research. The Office of Research has been in place since 2007, and since then we have been able to kind of help over 2,000 partners, imparting over 18,000 student experiential learning and over 2,000 research partnerships, drawing over 100 million in research funding. A few more metrics to go over. Just in the last year itself, we were able to help over 156 partners with their needs, and over 1,000 student experiences. We built around 286 prototypes, which specifically portrays the capabilities of the college to help industry advance their innovation. Briefly about the programs that the college offers, and this is divided into three subheadings, which is the future living, in which there are three sub-exchanges, which is the interactive design and experiential learning, a design exchange, which has to do everything about UI, UX, and design thinking. The other one is digital transformation, everything from blockchain, AI to extended reality. All those work falls under that exchange. Then there is the built environment. So anything to do with building science and construction would fall under that exchange as well. On the product development side, the Food Innovation and Research Studio, which helps everything with nutrition and recipe development, is a tag that we hold. And then the AMP Lab is the other one, which we'll talk in more detail about. Then we also have the FIT one, which the FIT exchange, which is a fashion innovation and textile exchange, which dives deeper into clothing, textile, and fabric. And then the last one, which is social innovation, which is with community development and Black Futures Research Institute, which focuses on community development projects. Touching upon what AMP Lab exactly is, in a very high level, we are an industry-focused innovation hub that enables local ecosystem partners, SMEs, from startups to SMEs, to become more productive and profitable through product development and process innovation. And when we talk about product development, it would dive from taking your idea from a napkin to MVP to prototypes, or from a process innovation side, which would include digitizing your processes or automating them to any level that would allow you to become more productive and enable advancement into the markets for you. Over the next slides, we'll go over some project examples that are very focused on the work that we did through CMCES, and most of the focuses are around developing products that enable that were used through keeping the circular economy principles in mind or using recycled materials. We also kept in mind the material capabilities while we were designing these products. So the first project we did was with a small company called Plastic Flux, in which we helped the partner. So this was our third project, and which went through CMCS. And in this project, we used number 2 and number 5 plastic to create planter molds for the partner. We did a lot of analysis on the number of on the plastic so that it could mold and hold in the mold for the partner. And though this is such a small step, it definitely is in the right direction of reducing waste from our blue bin. The next project was with a company called MEA Health. And this project, as you have recently seen, that there has been a global crisis after the single-use plastic after COVID, because everyone was using a lot of plastic PPEs and just throwing them in dump, and they ended up in landfills. So MEA Health is a corporation that we worked with who is trying to help hospitals, military organizations, and municipalities to kind of dispose their PPE right at the source. So for this company, what we did was we helped them develop a product which was a container that would be hosted in your location that would allow you to palletize your PPE. So what we did for the partner was we helped them come up with the process and the equipment. So we designed the equipment, designed, fabricated, and prototyped the equipment for them, in which the PPE would be shredded, extruded, and then palletized into very condensed small pallets that would be easy to ship, but also it could be sold back to the PPE manufacturers. The next project brings a different flavor to our projects. This project we did with a company called CMCES Converge Modular Homes, and CMCES Converge is going to be you're going to hear more from Ian in the next session after ours. But what we did for CMCES Converge was we after Toronto's bylaw opened up, allowed for small homes in your backyard, CMCES Converge went in and we helped them with designing modular and manufacturer model for small homes, keeping the circular design principles in mind by using products that have circularity in mind, but also using sustainable materials and minimizing waste. This next project brings another flavor. So this was a carbon capture project with a company called Nuclear Promise. The company works in the nuclear space, and this project focuses on capturing ambient carbon at the point source. So what through the project we tried to prototype and measure results for carbon capture using potassium hydroxide. And this video on the right, it shows the chemical reaction happening with the ambient carbon and KOH, and eventually it becomes potassium carbonate and settles down, and it can be drawn out. And this is such an interesting project that stands out from our other product development projects. The next project was in the luxury market, in which we designed eco-innovative barware that would allow you to flavor your drinks using recycled and reclaimed materials. So this is a luxury product that one of our partners is Helios Originals is developing that integrates reclaimed and recycled materials. And this goes back in emphasizing that how we can make a small impact, but be impactful by reducing waste, by reusing them into our future products and product designs. One last project that gives a technology flavor to us. So Recycene is a composter company that turns your food waste into organic compost. And what we did for and they have reduced the composting time from to 7 days. So you can use them in your in your houses, and they will convert your food into soil, into compost for you, that you can just put it back in your backyard. What we did for the project, for the company, was we incorporated AI into their composting, making their composting more efficient, and we did machine learning models for them on this project, and we were very successful on this, which this allowed us to enhance the efficiency and the nutrition assessment accuracy for the compost. That is the gist of some project that we did out of the 10 projects that we did through CMCES. And thank you so much, Steve, for giving me the opportunity. We're back to you.
Thank you very much, Arbab. That was a good presentation. And so next on the docket is Dr. Masood Akshik from St. Clair College. Dr. Akshik is the program manager and multidisciplinary scientist at St. Clair College's Department of Research and Innovation, a dedicated researcher with a postdoc in AI and robotics, and dual PhD degrees in environmental studies and nanobiotechnology. With a focus on pioneering advancements in research and development, Dr. Akshik leverages innovative mobile robotic platforms, agri-food robotics, and machine learning to drive cutting-edge solutions. His comprehensive skill set spans automotive engineering, robotics, machine learning, AI, environmental studies, quality control, and sustainable production practices, as well as nanobiotechnology research, such as microfluidics and developing new materials. With over a decade of experience, Dr. Akshik is committed to enhancing the efficiency, automation, and environmental sustainability of Canada's profile. His work not only advances technological frontiers, but also addresses critical challenges in environmental sustainability, positioning him as a leader in several fields. Dr. Akshik is deeply committed to equality, diversity, and inclusion in all aspects of his work, fostering a collaborative and inclusive environment that embraces diverse perspectives and promotes social justice. He acknowledges that his work takes place on the traditional, ancestral, and unceded territory of Indigenous peoples and is dedicated to respecting and honoring their enduring connection to the land. So without further ado, I'll allow Dr. Masood Akshik to take over and show you his presentation.
So can you see my slides?
Yes.
All right, great. Okay. So thank you very much for your time and for that kind introduction. So my name is Masood Akshik, and I'm from Department of Research and Innovation at St. Clair College. Today, I'm going to be presenting St. Clair's Circular Economy Project overview, and with that, you get a flavors of what is the capability of St. Clair College. So here's the image of the team behind the scene of every project. So we might be a small team, but we are very mighty. Trust me on that. I'm a doctor. And behind us, there's an army of course, researchers and students who are always there to help us and support the projects. So if I want to give you an overview of our policies on this project, we were engaged in 6 specific projects under circular economy grants, thanks to Lambton. And our key area of focuses were recycling and sustainability in manufacturing. We also had another area with integration of waste materials into new products. And also we delve into the technological innovation to minimize environmental impacts. So 5 out of that 6 project that I mentioned is already finished, done, and delivered, and we're like wrapping up the last one. So without further ado, I'm gonna talk about the project so that you get an idea of what's happening around here. Our first project was in collaboration with AccuLabel on the biodegradable fruit labels. You will be surprised that all these small stickers on the fruits would cause a huge environmental impacts and troubles for our ecosystem. Our objective was simple: to develop a fully biodegradable fruits labels and also meet the global standards in that area. The project highlights, I could say, is to establish a biodegradable testing protocols, and also we identify a testing benchtop equipments for cost-effective biodegradability evaluation and testings. And essentially that set us for having generation of compostable and biodegradable fruit labels. The next project is a little bit different. We delve into the recycling tire fibers with granulum. As you might know, the cars will still be around for a while, and last time I checked, we didn't have any anti-gravity propulsion system, so tires will be on the car, so we need to take care of the tires. Tires are causing huge problem all over the world, and the purpose of this specific project was to repurpose these fibers into something useful and then reduce the landfill waste disposal cost as well. And if I want to talk about the project highlights, was we find the potential applications of fibers in concrete mix and also soundproofing materials. We actually develop and test filtering machineries like vibrator shakers and also brushing machines. We established a process for fiber separations and successfully used the fibers in constructions and also insulation materials. So our next project, what with Raplitech, it's about the 3D printing filament developments. So what we did was actually we developed biodegradable filaments by blending PLA and PHB. Essentially, we created a series of filaments blends that we tested for strength and printability and utilized the coupling agents to improve the compatibility and reduce the environmental impacts. And we came into successful prototypes of biodegradable filaments blends, which is actually environmental friendly. So essentially, like in simple words, we wanted to 3D printer to be more environmental friendly, but we didn't want to mess with the process of printing. So that's what we were like focused on. Our next project was in the greenhouse industry. Once we say greenhouse, most people say this. What they don't know is that there is a darker side to the greenhouse. Once these things are done and the fruits are out, this is what we're left with. So this project, this specific project, we've worked with Undersun Acres, organic waste repurposing. So the objective was to transform organic waste into biofuel, plant-based packaging and fertilizer. So we conducted research on plant-based packaging. We explored the binding agents and pellets productions methods and also organic fertilizers. And we established the groundwork for sustainable biofuels and biodegradable packaging that can be used in by like all the greenhouse industries. So the last project that I want to talk about, that the last finished project is was in partnership with Laval, and we did some project with sheet molding compound waste. Sheet molding is great if you have any backgrounds in manufacturing. You'll know that this is a very effective way to produce parts. But the problem is we have a waste that we don't know what to do with, and we try to use those wastes into concrete to enhance materials properties and also sustainability. So we tested various concrete mix and incorporated SMC waste in those, and we evaluated mechanical and environmental benefit of SMC infused concretes. And we provided with sustainable alternatives to traditional concrete, and also we reduced the resource depletions and also support eco-friendly constructions as well. One thing which was highlighted here, and it was really interesting for us, based on the size of the waste, we can actually treat them as a concrete set retardant or advancer. It depends on the size. So that's something interesting that we can probably work on toward like a better, like eco-friendly construction for our future. If I want to talk about our ongoing project, so this project is with town of LaSalle. LaSalle is a beautiful town close to Windsor, Ontario, and our objective was to implement the IoT sensor into waste bins to monitor fill level, optimize collection, and reduce fuel consumptions. So this project highlight is we actually built the IoT device sensor from scratch and deployed the device across the selected municipal bins. And we also developed a data analytics platform for real-time monitorings and also fill prediction using machine learning algorithms. We enhanced the efficiency of waste collection and reduced the environmental footprints, and also we brought some cost savings for the town. So based on the deliverable, we delivered this simple dashboard that you can see some of these bins are being in the dashboards. Everything you need to know is on the dashboard, and you can see like what is the fill level on those. And one aspect of it that we are working right now is we are working on creating a automated route for GPS map for the truck drivers who are collecting the garbage, so that instead of like going all the way to wasting time and energy on the green bins, they can go to the one that's needed right away attention. Like for example, here they can ignore this one and then they can go directly to this one, and that route will have a huge impact on environmental emissions. So I would like to thank you for your time. And once again, I'm Masoud Akshik. I'm a program manager at Department of Research and Innovation, St. Clair College. I would like to encourage everybody to get in touch with us and let's form a better future for Canada together. Thank you so much.
Thank you, Masoud. I just want to, before I introduce the next speaker, just a reminder that we will be taking questions after this last speaker, and they will be through the chat. So if you have any questions, please put them through the chat, and we'll address them as we, in the question period after, which will be about 20 minutes following this last presentation. Thank you. So to introduce the next presentation, we have Yves Mathieu. Yves holds a bachelor's degree in mechanical engineering and a master's degree from École Polytechnique de Montréal. Since 2009, he shares his diversified experience encompassing the forming of thermoplastics, composites, and AFP to the Composite Development Center of Quebec, or CDCQ, as a project manager. The CDCQ helps businesses involved in the composite sector by providing technical assistance in the area of applied research, allowing them to improve the quality and performance of their products. These R&D activities are an addition to the St. Jerome College Training Composite Material Program as well, so providing, quality students. So without further ado, Yves, please take it over, and we're set to enjoy your presentation.
Okay, thank you. I should have tried to share my screen. Do you see it?
All good, yeah.
Okay, good. So basically the CDCQ is, thank you first for inviting us into participating to this presentation. So CDCQ is part of the CEGEP of Saint Jerome. We are basically a department of the college, and we do uniquely services to industry. We also attack in Canada. Let's see. Here. Does it change my slides? Yes. So the scope. So first, I want to say that talk about the CDCQ, what the scope and mission of the CDCQ. And we'll talk about a composite. What's a composite? I want to make a distinction between thermoplastic and thermoset materials. I want to discuss a bit of the CDCQ development axis and some of the project we did with the CMCES. So the mission basically is to increase the know-how and the competitiveness of our customer all through the value chain of composite. So we work with SMEs, molders, we work with people using composite, we work also with the suppliers of material. We have three different actions. We do technical assistance, apply research and knowledge transfer. So basically training, and we do conferences and things that we're doing today. CDCQ is involved in composite in every sector. So we are multi-sectoral. I used to say we are in space up the way to the sewers. So everywhere there's composite, we're there. I see here on the picture on the aircraft, also in satellites, energy, civil engineering, sport and leisure, and sewer types. Basically here in the sewers, we basically replace new liners inside the pipes, trying to basically repair them, prevent leaks, and without digging the whole street. So we work a lot in civil engineering in the sewers and cure in place pipes. So a composite, it's three materials. We have basically liquid resin, and we have fibers, and we have different additive. So the resin here is mixed with a hardener, and we have basically at the end a solid that is a mix of properties between the fiber we selected and the resin. We've been founded here in '89, so kind of a long story. We've been working in the Saint-Jérôme for that many years. And the college here is the only college in Quebec that has a training class for a technician in composite material. These technicians work in QA and development at industry like Bombardier Aerospace, Bell Helicopter, and all the other molders in Quebec, making composite materials. We have a facility right next to the college. We have a 3-story facility. The first level is the hands-on, where we make prototypes and testing processes and materials. Second floor is where we do all the material characterization. When you use metal, you have spec sheets of what metal can do. For composites, it's different because we build the material as we go. We select the fibers, we select the resin to have for an application. So every time we do a new material, we need to test that the properties we have defined are met during the process of transforming the liquid resin into a physical part. So we do a lot of testing. And the top floor, and that's where we have the brain, where we have basically all the engineers and the technician preparing the test protocols that we apply to our research. The difference between thermoplastic and thermoset. So basically, thermoplastics, all the plastic you see every day in your life, the yogurt bowl, the chairs in the yarn. So these are basically material that you can heat and remold after that. You grind and you remold and reshape. And you can use reinforcement in these plastics, but usually the fiber length in these reinforcements is broken up into the manufacturing process. So they're very small fibers, sometimes less than 1 millimeter long. And we are limited to the 20% and 30% loading into that. These fibers help building strength into the plastic. Thermoset is usually our polyesters and epoxies. So once we have the catalyst mixed with the liquid resin, it's we cannot go back to a liquid thing. It will stay stable even if we heat. It will degrade and burn, but it will not be able to remelt and reform. In this process, basically our fibers, when we do thermoset, the fibers are continuous. So we have a fiber, let's take a windmill, a blade that's 100 meters long. The fiber can go from one end to the other. So they're continuous. So these are high performance, really stiff materials. We can also have a lot more reinforcement. So we go up to 70%. So our access for development in sustainable development, we want to basically, we have in our facility a pyrolysis oven. Using that, we can basically break up the polymer into their basic constituents and separate them from the fibers. So the fiber stays in the bin here, and the gas of when the material decompose are condensed into these cylinders. So at the end, we have oils and gas that we can reuse, and we can reuse the fibers. To have a good cycle in this machine, we use this one first, that we know at what temperature what gases are produced to be able to set up, optimize the decomposition process. And the oils that we have collected here are analyzed in these machines to see what are the components. So when we do decompose acrylic materials, we can reclaim all the MMA, that's the acrylic monomers, and we can basically put that back into making new resin at the beginning. Other oils that are heavier are used into fuel or other processes. The fibers that we collect from the pyrolysis oven go through this machine. This is a SMC machine. St. Clair discussed about SMC. That's basically a paste of thermoset material with fibers. And this paste is made with this machine. Basically, fibers come on this line here, mixed with the resin. And at the end, we have a roll of SMC that is ready to mold, making automotive part mostly in cars that was used every car has SMC compound in them. When we do sustainable development, as we select the different fibers and resin, we also select other material, and we need to rethink our development. When we do a boat like this, we used to use different type of material. We use plywood to stiffen pieces, metal, all these are included in the boat. When we want to recycle the boat, it's really complicated because we need to segregate the component and try to reclaim them. This boat was made with only one resin, and we remove all the other material. So we're able now to reclaim the boat as a whole, not have to dismantle it manually. The resin we use in this boat is also a thermoplastic resin that we can remold by reheating. We have also a robotic cell. In that cell, we basically we are able to use tape of thermoplastics material. We can increase the positioning or better position the piece, the tapes into the part. So having better performance, using less material, and now we're using also thermoplastic resin here that we can remelt. And we have a project we did with the CMCES we're going to discuss in a few minutes. These are the projects we did. We did one with Old Castle. The main objective was to characterize the SMC and make it greener. So for that, we basically try to, when we do the paste, use in the paste recycled materials, different additive, different fibers, reclaimed fibers, and we try to develop a new SMC paste out of that. So at the beginning, we have, in this example here, reclaimed fibers that we added into our SMC machine. This is the paste that we produced. We see SMC is for sheet molding compound, so it's a sheet of a compound that we can mold. We heat that into a mold, compress it into that mold here in the press. We have a coupon, and that these coupons were tested to see how well these reclaimed material how well the material are being able to be reclaimed, and the properties of the system at the end. Also for the same company, we did an analysis of the how we can reclaim the material at the end. So the St. Clair College put it in the SMC into the concrete. We try to break it into the original pieces and try to reclaim it at a fraction of that into different new processes. So we can reclaim the styrene of the polyesters. We can reclaim the carbon black. These are also the oils that can be added into asphalt and fuel. The gas fraction that flew through can be used also to process, to heat the oven. This is the French version of the slide. We did a project with Garin. Garin is you see shovels. I know I pulled my shovel out of the shed this last week. So these shovels are plastics. And when you hit the ice in winter, you break the shovel. So we try to make the shovel with reinforced materials. So basically, at that point, we use basically tapes of glass, and it was, I think, polypropylene and other plastic like polycarbonate, and try to make the shovel out of that. And so we made the mold, we made the different pieces, and tried to produce a shovel with these materials that are increased performance, so thinner, and try to see if we can complete a shovel that will be more sustainable. We worked with Argon 18. Argon 18 is a bike company. They wanted to have a greener bike. Basically, today, all the bikes are carbon fiber and epoxy. At the end of life, we need to throw them away. There's no use beside burning the resin off, as we do in the first slides. But they're trying to have greener material, so we try to move into thermoplastic tapes, and these tape will be able to be recycled at the end. Also, thermoplastic has an advantage that they are a bit tougher and the more resistant to impact. These bikes are really thin, and they're suitable to break under impact and road impact. Let's go like this. So for that, we did try to do a seat post using the robot that we showed earlier. So to be able to design the seat post, we needed to have some material properties. So with this, we worked a lot with different manufacturer of tapes, carbon tapes, and we did some testing of these different material and verify their properties at the end when we have consolidated them into a seat post. And what we did, all the trims we did of these seat posts, we kept the leftover from production, and we were able to recycle the end of tapes and make the seat head of the post. So we proved that we can basically reclaim the material and use them into different pieces of the bike. This is another project we did. The paddle board, they are growing in popularity. Our partner wanted to have something that is greener. So we use in that paddle board flax fibers, so basically natural fibers. And we wanted to reduce the waste using these new projects. The result, we were able to do select material doing the house of quality selection method. We were able to select and reduce the cost in molding. We had made some prototype. We did basically a smaller scale version of the paddleboard to prove the process, and now we are transferring the technology to our partner. Magna, this is a company in Ontario. They're making SMC. In their compound, they basically have flame retardant SMC. And we want to reclaim that. We wanted to see what is the impact of using a flame retardant into a pyrolysis oven, how well we can recuperate the material, and if we can recollect the materials. And also we wanted to also here reclaim the fibers from the oven, and we do a paste. And the paste is also molded with heat and tested again using our testing material lab. So that's my presentation. Thank you, and I will answer questions. I'll let you to share. I think you took the control again.
Okay. Thanks, Yves, and thanks for the rest of the presenters, Masoud and Arbab, for those presentations. So just to address this, do we have some of the questions in there? Do we have access to the recording and the PowerPoint presentations? I believe we can provide access to the recording, and it'll have the presentation in it. I'll allow Andrew to correct me if I'm wrong, but I believe we can provide access to that. As for questions, all I'll start. If anybody has any questions for the either member or the committee in general, let me know. But I will start with kind of asking each a question about where do you guys see the biggest need in this sector? So what are you seeing from your companies as kind of the biggest need in this sector in terms of circular economy materials? So maybe we'll start with Arbab and then go down the list, Masood and Yves.
Thank you, Steve. It's costly to incorporate circularity into products in our life cycle. I strongly feel legislation would be the first step that would help us drive more circularity into our products and processes, then going down to support from various levels of government, but also the society as well, driving circular economy products and changing your needs that reduces the waste that we all create would eventually enable us to reduce the amount of waste that gets us to this point where we have to now worry about the landfills and all the carbon emissions and GHG emissions that are concerning us with the huge climate crisis.
Masood, what is your opinion on this?
Oh, hi. Okay, so if I want to talk about that, like mostly I could say the policy and regulation is very, very important. I was involved in a project, and the part that we built was 50 cents more than what it's supposed to, like what the supplier was paying. And it was 50% better in environment in terms of environment, but it was 50 cents more expensive. So they totally disregard the part because of that expense. So I'm getting a sense that there should be some regulation forcing everybody to be like more environmental conscious. And I also want to add the awareness of the people as well. That's really important. Like when there are a lot of noises out there that are like showing everything normal, but it shouldn't be. Like we should be talking and advocating about like these things are really critical for the future of Canada. We need to be getting more involved in circular economy projects, and like every like I would say even like every college should have a mandate to follow those kind of projects.
Okay.
Go ahead.
On my side, what we feel is that the industry need to know if they can recycle the material. The thing that we need to know the amount of material available. Let's say we have someone want to recycle the SMC. Who will take the powder that we will make? If they don't do it locally, the knowledge of the in French we say gisement, the level of material available for an application. If someone has an application want to use recycled material, they don't know if they have availability of that material, and it's probably far away from them. So the knowledge where the material is possible, or where can I send my material out to be recycled, and how to do a route to travel the material between who will dispose of it and who will need it. So we need to find a way to know where are the different material we want to recycle and where we want to use it. And people don't know that. It's very difficult to recycle if you don't know. Let's say I want to do a part with recycled glass. Do I have enough recycled glass available in my region? If not, then I won't do it because I won't have the material available. So the knowledge of where the material is and how to recycle it is not there at this point. So I think we need to, and that's what we're trying to do in our region, is try to see who has material, where is it, how we can recycle it, and can we travel it without high expense into traveling cost between the facilities. But that's what we need to know, where the material is, where we can do with it.
All right, and so I'm gonna thanks Yves, thanks everybody. So I'll move on to the next question in the chat here. So it says, I appreciate that you are labeling your solutions greener. Are you also involved in R&D involving non-oil gas toxic additives Example, truly environmentally friendly materials that biodegrade in a safe manner to our entire ecosystem. So I can answer that. Basically, that is the idea of the CMCES. We do a lot with, bio-based materials, both bio-based, biodegradable, and bio-based as replacement for oil-based materials. And we deal a lot with also recycling materials. So hopefully that they never get into the environment. Well, that's, not 100% possible. This right here is the goal of the CMCES is circular economy. So where we can, using biodegradable, bio-based materials. Where we can't is ensuring that the materials that we do use either will last and won't end up in the environment, or can be recycled and into a circular based system that will utilize its own waste to create the new materials. While not every single project will be one of those, and there is a need to improve even some of the oil and gas based materials, but the main goal and highly sought after, the projects are made from bio-based or recyclable material. So that is kind of the goal there. I don't know if you guys want to add anything to that, or if I covered it. No, all good. Next question. Perhaps this is upcoming, but I would be curious about any examples of key success stories, ultimate commercialization of some of the materials that you have put R&D into. We did go over some of that. I don't think we focused on the actual commercialization, because that is a bit out of our hands. So we get a solution that's ready for commercialization to a company, and then it's the company's goal to take it there. Now, we do have some success stories, and I'll ask the team if they have any right now on hand, they can go over them in less than 20-30 seconds, so that we can keep going. But one that we have is we've been working with one company to develop a bio-based PHA solution. So this is bio-based, biodegradable material. So polyhydroxyl alkanoates, either PHB or PHV, valerate or butyrate. And they now have a solution where they're working with different companies, and they're actually selling this as part of material development. So they have a calculator that you put in the amount or the qualities that you want. It calculates the ratio of different PHBs and the additives needed, and they can actually make the material for you. That is commercialized. I don't know the scale. Unfortunately, sorry, I'd have to reach out, but I know they are selling that on the market right now as a solution to replace, different materials. So, substituting like packaging, single-use plastics or stuff like that with PHBs right now, but I think into larger applications going forward. So if any of the other team has a quick example they want to just run through.
I'll add to that.
Sure.
Our partners, because our projects were product-based, most of them do commercialize. So Plastic Flux is selling their coasters as of now that we helped them very initially to do them. VSicene is also selling their composter. They have almost sold 150 of them. So it definitely, as Steve says, it's up to the partner to commercialize, but definitely helping them get to a stage where they can commercialize. We come in and complement their skills. So thank you.
I can add to that. Basically, on our side, I showed the project with the flax. So that's bio-based material. So we do have some success in using bio-based material. There's also some resins that are partially bio-based. But on our side, we try to do energy recovery from the composite material. So with a lot of petroleum in there. So we have a route. We collect some leftover from production, and we go to the cement factories to reclaim the energy out of these solids. So at this point, it's not a reuse, but basically it's a reuse of energy that we need to burn out the clay to make cement. So we have a success in that.
Thank you. So this next question is actually kind of a follow-up to my first question about the, utilizing non-toxic materials and biodegradable. So they say recycled plastics have a limited lifetime and are in the environment where they biodegrade into, micro nanoparticles that are toxic and ubiquitous already. So that is a problem, yes, and that's why our focus is to try to get away from that. So just like I said, the PHAs are biodegradable. They will, even in non-compostable conditions, they will biodegrade in relatively short time of 1 to 2 years. So once they form a microplastic, they have a limited lifetime in the environment. And, you know, we are working, composites themselves are made from, you know, woody biomass, right? Like, you know, lignocellulosic sometimes and that. So, you know, there's a lot of avenues we're going there. We're not perfect. Never said we are. But we are trying to, one, increase recyclability with we can, so it doesn't just end up in the environment after it's single use. And two, increasing the amount of this, you know, bio-based biodegradable materials that then won't pose a problem later on in the future. So it is a slow progression, but it is, you know, a progression that we are making. So thank you for the question. Right. So next one. Sorry, I'm just trying to move on here. You know, make sure we get through a couple of them. For all panel members, do you feel there is currently a funding gap for innovation as it relates to supporting circular economy related projects, businesses, etc. in Canada at present? What do you feel could be done to address this gap? I will maybe put this to the panel and see what they think, if anybody wants to jump in on this one. So what is, you know, the gap as it relates to funding, basically, or gap in funding innovation? Yeah.
Well, there's always a gap. We always need money to make these developments. There's also a motivation gap. Masoud talked about that. If it costs 50 cents more, people won't do the gap. If we want to reduce landfill, we need to increase the price of landfill. So we need more legislation to promote that and try to help industry find new ways. People in industry, it's hard to make innovation. Sometimes it fails. So we need to help them do innovation, and we need to motivate them by, so well, if you don't do it, you're going to spend the money anyway into your landfill, and we need to stop that. So we need to increase the price of landfill.
Anything else from the panel? Any other ways? I think the key is funding and, like you said, legislation. So there has to be a drive to do it. No one's going to do it, you know, intentionally. And right now, you know, unfortunately, the gas prices are nice, but with oil prices being so low, that keeps the, you know, the oil-based materials low as well, right? So, you know, consumers are going to go on price, right? So everything we're doing is to reduce the price of these bio-based materials, but right now it is still priced higher. So the key is a little bit of legislation, you know, and, you know, just getting the technology to a point where it is that, you know, economically feasible. So making sure that, you know, we can push this technology forward. So one day it is competitive with oil-based technologies. So, right. So the next question, there was a mention of a 50-cent addition for a solution that has a 50% environmental improvement. Any way to quantify that into a positive ROI to incentivize investment? Also along the same thought, is there a circular materials certification database by geography? In terms of quantifying environmental improvement, I'll put this to Masoud. He seems to be the one qualified to answer this, as his degrees, you know, show he's got environmental degrees and material-based degrees. So Masoud, you know, how would you quantify an environmental improvement in this area?
So the only problem we have here is that many of the corporations are run by the profit, not anything else. They have, of course, they have social corporate responsibility, but not all of them are B certified corporations, and even not all the B certified corporations will prioritize these things over profit. So the first thing that we need to rethink would be, if they're not going to do it what they're supposed to be doing, like there should be a kind of a regulation forcing them to do, or there should be a method like says mentioned, that like increasing the prices somewhere else so that they can avoid these kind of things. One thing which was came up with one of the discussion that we have with a few friends was that actually, like, even carbon tax is not what it should be. Like, it's very cheap for companies to just pay and get rid of the numbers rather than just do and something meaningful toward it. So those things are, I think, things that are in process. We are not there yet, but we need to rethink the whole system as all in one. Like everybody needs to be on board, like whether it's a college or university, whether it's the a regulation body, or whether it's a company. We need to just sit down and talk how we can proceed with that, because we only have one planet and we are like kind of ruining it. So that's all I have for that.
Thank you very much, Masood. Go ahead, Ethan.
In colleges, we need to train our relève, or the one coming up, tell them that it's feasible. If we take care and take the time, it's feasible. Don't accept to throw away things. We need to tell them that it's feasible and go and push your company to do it. So we have a part to do in our colleges to say that to the student. Push into your organization where you're going to work that is feasible, and we need to do it.
Yeah, mindset is really important.
So I am going to answer one more question. I think it's a good question to address as circular economy, syndicate. So because we are into our break now, so I don't want to get too much in the break. We need some time to recharge and refresh. So one last question. It does state, how are you addressing the issue that breaking down and recycling material usually costs more to produce than creating virgin materials? And there's a follow-up in terms of energy and fossil fuels use. So I'll start with this real quick is research. So research is the key. Right now, we can make these virgin materials because they've had, 150 years since we've been making plastics, well, originally working with oil, 150 years. Plastics have been around since World War II. They've had the time, right? Time to make these things, these large industrial processes efficient. So we need time to make the alternatives efficient. Now, in terms of, the cost of breaking it down and everything, yes, there is a cost to breaking it down rather than using virgin, and that's the material itself. Plastic is a material that's meant to be stable, that's meant to be, not easily broken down. So to break it down is hard, but there are different methods. So you're seeing new methods come up, and some of these won't be good methods. They won't ever be economical, but we'll get to the point where one is economical, I think, eventually. So it is time and resources that have to be put in it, same as developing those materials from fossil fuels. Time and resources went into it. It didn't happen overnight, and things have been getting better, and we just need that time and resources. Any quick additions from the panel that they want to add to that? Nope. Thank you, everybody. I'm sorry we didn't get to all the questions. Things ran a little overtime, which is always great. But thanks. I will turn it back to Andrea now, and she will introduce or go on with the rest of the conference.
Thank you, Steve. Thank you to all the presenters of our first panel. And thank you to our audience members who submitted some great questions. It shows to the great quality of the topic that we are addressing today. We are going to take a quick break. For those of us who are joining Eastern, it is lunchtime, so maybe go grab something quickly and come back for 12:25. We're going to have our next panel that's focused on successful circular economy projects and initiatives. So we'll see you back here at 12:25 Eastern. Thank you. Hello and welcome back. We are going to begin our next panel. It will be focused on successful circular economy projects and initiatives. And I will introduce our moderator for this panel. Jeff Van Hume is a trained polymer chemist with a PhD specialization in urethane chemistry. Jeff is currently the Assistant Vice President of Business Development for Ontario Centres of Innovation, supporting the Pan-Provincial Business Development Network, while continuing to provide business development support for the London, Ontario, and surrounding region. His areas of interest and expertise are in materials and materials processing, chemical processes, mechanical design and machining, automotive, and entrepreneurship. I will pass it over to Jeff, who will be moderating this panel.
Perfect. Thank you, Andrea. I think you missed the part about me teaching a circular economy course for Lambton College, but glad to be here today to support this fantastic panel on successful implementation of circular economy projects. We've got 4 fantastic companies represented by 4 individuals that are primary within those organizations, and I'm thrilled to be able to introduce them and go through this today. So what we're going to do, I'll just do a quick introduction of each of those speakers, and then we're going to give them an opportunity to do a quick presentation of about 15 minutes, followed by about 20 so minutes of Q&A after that. And kudos to all of you for the questions that you provided in the previous session, hoping that this will continue in this session as well. So to kick things off, I'm going to just introduce Ian Ho real quick. Ian Ho is a partner at SysConverge since 2015, leads advanced engineering solutions for diverse commercial clients like Mount Sinai Hospital, University of Toronto. He's a mechanical engineer and an esteemed lead AP certification holder as well, and which underscores his dedication to sustainable engineering practices. Following Ian, we'll bring up Amanda Horn. Amanda is the founder of Lowless Blue Beauty. Amanda is a Canadian ocean leader focused on making ocean and water wellness as part of everyday life. She's done a number of sustainable consumer practices, or implemented a number of sustainable consumer practices. And she is also a champion for circular solutions and ocean conservation, aligning with the UN Ocean Decade for Ocean Science and Sustainability. Amanda is also a mentor of startups and advises on building process-driven brands. So fantastic. Then we have Charles LeBlanc from Oldcastle Infrastructure. Charles is a graduate of Cégep Saint-Jérôme Composite Training Program, who went on to study material engineering at Polytechnique of Montreal. He's been with Oldcastle for 22 years and has held a number of different roles there, and currently in the role of R&D manager. And then finally, we have Bill Santos from Nova Chemicals. He's the director of polyethylene technology and circular polymers. Bill has a PhD in material science and is the director of PE technology and circular polymers at the Center of Applied Research for Nova Chemicals in Calgary. His role is accountable for the development and delivery of new game-changing technologies in the areas of polyethylene and circular product development. Bill, and I can appreciate this, being in London, he's a Western University grad where he did both his BSc and PhD degrees there in chemistry. So with that quick introduction, we're going to start off here with coming back to Ian and allow him to share his presentation here very quickly. Hopefully, Ian, you're there. You are. Awesome. And so the topic today, as you see, is on Toronto Modular Home Project. So Ian, over to you.
Great. Thank you, Jeff, for the great introduction. Hi, my name is Ian Ho from SysConverge, which is an architectural engineer firm that provides solutions to the built space using technology. Our solution serves our clients range from different phases of the building, from conception of a building to the built or existing building. But one of our projects that our research division had partnered with George Brown College for is the Sustainable Modular Housing Project. So the team consisted of the George Brown team, which had included the project manager of Morgan Watts. There is Nisrin Al-Sayed Suleiman as the principal investigator, and the research team of Naveed Ismaili, Naseem Revei, and Rahele Rahimi, and of course the SysConverge team here, myself and Edwin Luke. So why modular homes? And what I start out with is imagine a future where sustainable, affordable housing is accessible to everyone in Canada. This dream is within reach, and the Modular House project offers a compelling roadmap to achieving it. Canada's housing crisis is a pressing issue right now, particularly in cities like Toronto, as you see, where the median home price dwarfs the average household income. This disparity creates a significant barrier to homeownership and for many, and it fuels the demand for affordable housing options. So our approach tackles this challenge by offering a solution that prioritizes a sustainable design, affordability, and modular home. This project envisions a home that starts as a tiny home measuring 18 square meters, almost 200 square feet, designed to house two people comfortably and can be expanded or customized in the future. And this compact size not only minimizes the environmental footprint, but also reduces the construction costs, making it more attainable option for those who are seeking affordable housing. So summarizing the project goal, what we set out for and what are the requirements is that it meets Ontario Building Code because we are located in Ontario right now. It fits two people comfortably. As Arbob indicated, we first focused on this because of the new garden suite option that is now available in Ontario, and circular design, where the home is modular in nature throughout its lifespan. So it can modulate or increase or upsize horizontally and vertically. The use of sustainable materials during production and construction, and of course, sustainable during its operation up to its end of life. And what we set out for is that this building would cost, and this is including the materials and fixtures such as sinks, showers, HVAC systems, and fridges, would be at $75,000 Canadian. This is without labor, but this is what we set out for. So at the heart of this project, we looked at multiple materials, but at the heart of it, the modular home is made out of cross-laminated timber, or short form would be CLT, which is a sustainable building material with exceptional strength and durability. The CLT structural strength made it suitable for multi-story structures, offering flexibility and expandability of both especially vertically, in order to create a denser housing solution. Its inherent sustainability further enhanced its appeal. So as it has a low carbon footprint and can be easily deconstructed and recycled at the end of the home's life. So we looked at and considered different existing and upcoming materials, and two that are very sustainable are rammed earth walls, which is really using the soil of where the house is located, and hempcrete, which is focused mostly on hemp. They are great in a sustainable viewpoint. The issues were that structurally it was not good enough for what we were looking for. We would not be able to build vertically properly. And also the thermal properties. Though it is great on other technical properties, we wanted to make sure that there was enough insulation where the walls were not too thick so that we can achieve a passive house certification. The other materials we looked at was ICF and EIFS. ICF is used quite a lot right now. The issue we had with, and technically it is great. It is strong, it is thermally efficient as an insulation. But the issue is it does heavily rely on concrete at the moment, which is something that we wanted to veer away from, as it didn't meet our sustainability requirements. EIFS, or EFIS, some people call them, is great in the insulation value, but structurally it didn't meet our requirements to grow vertically, so we did not go with that material as well. So these are the top 5 materials that we looked at, and you can see ICF and EFIS and CLT. Well, actually, ICF and CLT are the main ones that provide a good solution. Again, why did we not use ICF? Is because of its sustainability issue. So that's why we went towards the CLT option. Of course, with every pro, there are cons. So CLT does have cons. It is made out of timber. So you will have concerns of termites, water damage, and vapor permeability. But we also do have solutions built into our design that would alleviate these issues. So for termites, we would elevate the building or the CLT portion 50 centimeters above ground so that we would reduce that termite issue. Water damage, we would apply a water barrier to the assembly and also drain the water outside of the house, which is very typical of existing construction now because our houses nowadays are still built through timber. And vapor permeability, similar situation, we would have a vapor barrier on there, just like how houses that are made of wood right now have. So it is not a big stretch in the industry to have this solution. Now, the true ingenuity of this project is in its modular design. If you imagine you purchased a garden home in this case, but your needs in the future change and you require more space, your family grows, or you need more storage. As homes are currently built now, it would be quite a costly endeavor to customize or expand your house. You would need to demolish a section portion of your wall, and a lot of that would mostly go to waste. And you'd have to redesign and reconstruct the new addition. But imagine if you could disassemble the home and add pieces like a Lego piece, and the pieces that you disassembled were able to be reused. The house could be easily upsized or downsized by adding or removing panels, adapting to change of the needs of the occupants. So our solution incorporates the use of prefabricated panels that can be easily assembled on site. So if you look at this photo here, this is a sample of the panel, and it includes a siding. This is the exterior port. The insulation, which is about 180 millimeters thick, to add this insulation to the CLT, which is 3 layers. Now, why does this look like this? We do have this little tongue and groove that we created, and this is to help minimize any air gaps, water leakage to the system. But more importantly, it allows your modularity. You can snap this into place and disconnect it as you need in the future. And this connection system allows for a quick and easy assembly, requiring minimal specialized labor, which we believe would help in reducing construction costs. Now, if you look at this picture over here on the left, I'm not sure if everyone can see my mouse, but you'll see a 3D printed version of this tiny home. It's not 3D printed as a whole. It's actually printed in the panels as we designed here on the right-hand side. So what we did is we 3D printed each panel and then put it back together. And when we presented this project in person at George Brown College, it was great seeing some people come in and start disassembling and reassembling the house into different configurations. So they kind of understood the modularity of this system. Now, further to the panels, these are the panels that we created. And these would be panels that you can add or subtract as you go along. But you have the first one, which is just a regular side wall, and it would have no windows, doors. Then we would have a corner piece. The second piece, being the corner piece, would allow you to make your 90-degree turns onto your house. So if you need an addition, you could put another corner piece to expand outward. Then, of course, you need windows. So there would be a panel section that allows larger window openings, door openings, and smaller window openings. And these last three here are the panels that allow for your roof assembly. So just to show everyone how that would look like, this is an expanded view of the tiny home with all its panels on the side, including the roof. And how it would come together would look like this. So you see, it would connect to each other, coming out to the tiny home. So this next slide shows the layout of the tiny home that we started out with and we focused on. And you see there is a shower, there is a washer dryer, your sink, your toilet, your range, which includes a range hood at the top here, your sink, your fridge and freezer, and to your right, it would be your living quarters, your bedroom, and if you have modular furniture, also your living room. Now, some people may not want to live in this type of situation. Some people would find it very comfortable. But the reason why we made this modular is for this next reason of actually building up or horizontally or vertically. So as you can see here, at the top corner, you have the single tiny home that we already showed. But because of its modularity or the possibility of being modular, you can stack them in the future as you see fit, or you could build them horizontally. Now, the building does not have to, or each module does not have to include your sink, shower, washrooms. You can take those away and create that as a separate room for living space, or for storage space, or what have you. So this is the portion that we really like. But again, this modular house goes beyond just mere construction and customization. The whole point of this is that it embraces the sustainable living principles by incorporating energy efficient design features and aiming for passive house standards. So how do we achieve this? Well, what the team used was we evaluated all the new and existing materials that exist, and we compared them as you saw in the beginning. Then our next step was that we designed and optimized our design through 3D software. We compared some assembly methods during pre, post, and during construction to see how that situation would look like. And at the same time, we incorporated energy analysis and modeling softwares so that we can compare the performances during the design with the architects and the engineers so that this is realistic. So to conclude, this project presents a possible solution to the affordable housing crisis in Canada. With its modularity throughout its lifespan, pre, post, and during construction. The sustainable materials used will help the circular life during and after the end of life of this building. This also meets the passive house standards, so that further helps the sustainability during the operation of this building, which can be created economically and also has a potential for increased future value, especially when the building is expanded and has the availability for customization in the future. However, its success hinges on collective action from various stakeholders, such as, like we talked about earlier, government implementation of policies that incentivize the development and adaptation of sustainable and affordable housing solutions like this modular house, or methods for public education on what the long-term and short-term monetary costs are for sustainable developments. Greater investment support would also help for companies and organizations that are developing innovative and sustainable housing technologies. And of course, communities to advocate for regulation that allow for the construction of houses and of this nature and homes to be modular, such as this. So by embracing the principle of sustainability, affordability, and modularity, we can create a future where everyone in Canada has access to safe, a comfortable, and environmentally responsible home. But this modular house project is not just a building, though. It is a solution showcasing what is possible when innovation and social responsibility converge. So let's work together and hope to make this vision a reality. Thank you.
Excellent. Thank you, Ian. So many questions, but I'm going to leave them to the end. And I'm hoping that the audience is going to provide some questions as well as we go here. So on to our next speaker. So we have now Amanda Horn, as I mentioned, the founder of Lowless Blue Beauty, and title of her talk today is Designed to Dissolve, Zero Waste and Water Safe Wet Wipes from Sea to Soil. Amanda, over to you.
Great. Thank you so much for having me. It's been great to be part of this day so far and excited to join the conversation. My name is Amanda Horn. I'm based in Burlington, Ontario, and I've had the pleasure of working with Lambton College to develop the prototype for my biomaterial over the last year. But I honestly never intended to start a beauty company. I really just wanted to start a conversation around ocean conservation, coming from a background as a marketer in CPG. And post-pandemic was really starting to feel a little bit of that guilt and was starting to have my own sustainability awakening, which really started in the water. Always had a very special connection to water, which everybody in the world is connected to the ocean, no matter where in the world you are. That was really the mission behind the brand, was to start to bring people into that conversation in the everyday and have them start to commit to ways that they can make small everyday changes that would reduce the impact that our activities as humans have on the ocean. So ultimately, we wanted to start a conversation on water scarcity, plastic and water pollution, and ultimately waste management, which was how I, through my own research, ended up falling into this notion of circularity. And if we truly wanted to design a brand that was not just ocean themed, but was truly ocean safe, there was a lot of research that I was going to have to start. So as of last April is when I officially started my project with Lambton College and the team there. So the goal was to produce a MVP of my biomaterial that is made from seaweed. And the goal is to be able to apply this material to the beauty and personal care industry. One, as a brand builder, I know that there is so much power in the way that we can engage consumers in this conversation around responsible consumption and production, but also wanted to start to model and encourage brands to try and design their companies as circular and sustainable from day one. So I am a marketer, very much so, and not a scientist at all. So not knowing where to start with getting going on a project like this is why exactly, if we're looking at supporting Canadian entrepreneurship and ways to support entrepreneurs in that ecosystem and be able to eventually commercialize those solutions, there's so much value in programs like this. I'm very grateful for this organization. But myself, I am a dive master and a free diver, and it was ultimately through spending so much time in ocean and water, and when I see more plastic than fish in the ocean, that was ultimately that call that I knew that I wanted to innovate and be part of this space and ultimately contribute to Canada's blue economy. The beauty industry it's really ironic that we've chosen this one. We are one of the largest polluting industries, I believe, on the planet. So much so that some of the branding we use when we talk about colors and pigments are actually referring to our fossil-derived materials. So a lot of black inks you'll see are actually named carbon black. So there's so much rebranding that has to take place across all those consumer touch points. There's so much opportunity for us to engage consumers in that conversation. Ultimately, what we want to be part of is leading a new safe, a standard in water safe ingredients and innovation. So making sure that ingredients that are used are going to be able to biodegrade safely and not bioaccumulate in marine life and aquatic systems, because ultimately ocean and water health is our health as humans as well. And all of this came together for me when I started meeting marine social scientists whose work was actually spent investigating what the mental, emotional, and wellness benefits of spending time on, in, or near water are for us as humans. And so that really led to our big, broad mission for our company, which is one, yes, to design a circular blue beauty brand from day one, but ultimately this vision of water wellness for the world's bodies of water. And as much as I started to realize the parallels between our health as humans and our world's waterways, that's really where that started to stick. And everything that we do, every decision that we make going into our design is really rooted in that concept. And our mission here is to inspire the next wave of responsible businesses, but also engaged eco-conscious consumers. Now let's skip this one. So on this mission to design a purpose-driven brand rooted in ocean conservation and looking at how we've integrated circularity, that first touch point is it's in our name. So lowless actually translates to waterless, and it was meant to be this call to action for if you could choose one thing in your decision to become a more eco-conscious citizen, if you looked at ways that you could reduce your water footprint in your everyday life by shortening your shower, trying one of our no rinse products, that will ultimately include wet wipes when we move to commercialize those. Next is that from a supply chain standpoint, we really started speaking with researchers, scientists, sustainability experts early on in systems thinking and how we could see what was already happening within the Canadian innovation space and figure out what kind of raw materials would make sense to bring into our supply chain and what kind of partnerships and what did we need to co-design. So that was not, so that we were really designing a nature-based solution. And Lastly, when I look at our alignment with the global goals and sustainable development goals, what I think is definitely missing from SDG 12, which is the one that we would certainly most align to, is the idea that as a marketer, we need to take responsibility for what happens post-consumer use. And so that is ultimately where this notion of circularity comes in. So it's not only responsible consumption that we want to promote and educate on, call our brands to be more responsible in the products that they produce, but ultimately, how do we limit or eliminate greenwashing, false claims, call for more transparency, and create those important educational conversations with consumers, but also with brand founders? Because I really struggled as I was looking for packaging early on for our first product. You go to any packaging website, and under their drop down for sustainable packaging, there's a lot of greenwashing happening in that category. So there was a lot more research that I found I needed to do on my own, and very glad that I have access to esteemed researchers who can help navigate these uncharted waters. So ultimately, our brand is designed for, I guess I'm the model consumer with a lot of my friends. We traveled a lot for work, and ultimately traveling with your beauty and personal care routine is a nightmare. Things are getting confiscated by airport security a lot of the time. So you're having to choose single-use disposable items. They're packaged in little tiny virgin plastic most of the time, which ultimately don't make it into any waste stream, end up back in our landfills and wash back into our waterways. So that was the biggest pain point and frustration from this design concept. Next, we wanted to really focus in on who's going to be that model consumer who already understands the urgency behind ocean climate solutions, who's looking for these eco-conscious options. So we wanted to build in tandem with ocean scientists, with ocean creatives, and sustainability experts, because we knew that they would be our early adopters. So building community within our ocean networks and climate conversations was important. Next, I was very lucky to come across actually a lab that was not too far from me, just in Mississauga, who have been focusing their organic chemistry research on water-safe skincare and science. So again, those are ingredients that biodegrade well in water and don't accumulate in marine life. That's for things like SPFs and sunscreens and different filters, to just our everyday products that we put on our skin and end back into our systems as well. Packaging, we've already gone through, and then to sum up, yes, this is our entire marketing premise, but we really do believe that we can have conscious and convenient options that do coexist, and that's what brings us into this biomaterial space. So a lot of we talked about so far, how are we going to be able to commercialize these? Like when I was looking for packaging solutions, seaweed kept coming up a lot. But it wasn't yet commercially viable. It was extremely expensive for an independent beauty brand to be able to take on those costs at such an early stage, but still wanted to put our foot into the ring and start seeing what the conversation was, and really hoping that we're going to start seeing policy shift, just like a lot of what's happening in Europe, for the demand for home compostable and bioplastics to be adopted as an alternative solution to fossil-derived ones. So ultimately, we ended up with 4 variations of our prototype. We're calling it Miroir biomaterial. So I was actually marketing wine before I moved into water. And so when you actually look at an oyster, the liquid that is inside the oyster is called miroir. And that just really symbolizes that where your food is coming from, or whatever body of water your seafood is coming from, influences that taste. But we wanted to really massage that out, and have that mean for us that the ocean is really reflected in everything that we do, every decision that we make, and certainly in our DNA as humans as well. So with these variations, our next step will be to move forward with the 2 that we have selected. One will be completely water soluble and dissolvable, and the second is home compostable. So just at our next stage of we're scoping out the second phase of the project and really looking forward to continuing the work with Lambton. Seaweed as a renewable source, one, it doesn't need land, freshwater, irrigation, or any inputs. It is a solution that belongs to the ocean. It is a great carbon sequester. There's still so much research being done on how we're actually able to measure that impact, but certainly from the network and the psychologists that we've spoken to and other organizations that we want to be able to leverage within our business model. There's a little bit of a surge here in Canada, so lots of support for continuing this research. Ultimately, our plan would be to be able to achieve scale by partnering with global brands in CPG through beauty and personal care. But where we really want to start working in our early pilots in 2025, we'll be focused with regenerative travel and hotels. There are many hotels worldwide that are really starting to bring conservation into their guest experience. And that is what we really want to deliver so that they can start delivering their sustainability platforms at a guest experience level. So ultimately, our next steps now are to deconstruct this prototype that we have and really build out the key players that we're going to need in the supply chain and take this out of the lab and actually get it into market. Continue with some of our compostability and water solubility studies and see if we can improve the time that we're actually able to see the results of those materials degrading. Continue to consciously work on the business model and part of several accelerators, have access to some great advisors and experts in the clean tech, climate tech space, which is extremely helpful, but very much looking forward to continuing the work with the department. And certainly in Canada, we're positioned very well to continue to leverage our abundance of natural resources. Fitting into this niche of ocean innovation, there's significant opportunity in here. We do have the largest coastline in the world, which is about the equivalent of traveling around the circumference of the Earth 6 times. So that's a lot of space. We've got opportunity to partner with Indigenous communities and create real social impact and job opportunities. Also support a lot of early career ocean professionals and scientists by getting them involved, and certainly start to tackle this large marketing and communication problem that we have around climate change. So very grateful for the time and ability to present this afternoon. Grateful so far to all of the innovation partners that are our partners that are in our ecosystem, whether that's been through advice or funding to date. Definitely continuing to leverage all that exists here within Canada. So thank you so much. Very much looking forward to connecting and answering some questions potentially later, but let's keep you fresh, smooth, and the ocean clean is our slogan. So thank you so much.
Excellent, Amanda. Thank you so much. Excellent slides, by the way. Really appreciate all the imagery there. Fantastic. All right, so we're going to carry on here with our next panelist. So Charles LeBlanc, as I mentioned, Research and Development Manager at Oldcastle Infrastructure. Charles, going to cross my fingers that you're there and you're going to share your screen.
Yes, I'm there.
Okay. Fantastic. And there we are. Okay, so I can see your screen. Go for it.
Excellent. Okay, I will start just to introduce you a little bit who is Oldcastle. Just Oldcastle, it's a global company. We are like number 1 in asphalt, number 3 in aggregate, number 5 in ready mix. We produce the powder, cement. We produce the clinker, everything. We have also another division. It's architectural. It's like paver. We produce, and on my side, I'm on the plastic and composite division. This is, but I will just. It's a global company. We are over 80,000 people working for CRH in 32 countries. And in North America, we have multi-facilities, 80 locations in my under my divisions on what I'm working on. And I'm the material engineers for thermoset. And we produce also some thermoplastics in other facility. I picked like I started a project a couple of years ago, just how recycling polystyrene. I know polystyrene is a plastic that we didn't really recycle after. And a little bit like how the other speakers talk about. Just in my case, I try to find a way just to be cost competitive because on manufacturing standpoint, just if it's more expensive and I use recycled material, that doesn't work. Just that's why I work at the beginning of the project, just control the feedstock, just making sure it's the cleanest as possible. That's why I work really closely with my vendors. It's Eco Captations in that case. Just Eco Captations, you have some center where people can bring all these polystyrene, expanded polystyrene, and in that case, like you can see, just in my plant, all our employees can bring also all their polystyrene. And after that, just we have like 90% of time we receive the right feedstock. That's why we don't need to spend a lot of money to sort all the plastics and just and you really starting using compounded for our production. Just after that, just the second operations will densify the EPS because just for knowledge, 1 metric ton we fill 53 footer truckloads of expanded polystyrene. That's why we densified, and that way we can densify and fill 2 super sacks with that metric ton. After that, we just we pulverize because in our process we want to keep some efficiency and how we use the polystyrene. We use as a low profile additive. We didn't use like because in that case I produce polymer concrete, and we don't use as like a filler inside. It's really we use the chemical component. That's why just when we densified, we should make sure just we didn't degrade the polystyrene molecules. We keep it as is, just because we want all the benefit for control the shrinkage of the finished good. After that, we dilute that polystyrene inside monomers, and we mix it with all the resin. We already claim a patent on it, and the beauty on our production is our product it's black. For that reason, just we don't need to sort all different colors. We can use any colors, and at the end, we just add our black pigment inside the finished good. Next step, just we want to implement that process in other manufacturing plant. Actually, I have 2 manufacturing plants that use that system. We use 1 metric ton per week, and it's not sent to the landfill. Part of the economy, how we can make it cost-wise, that product is landfill also contribute just to keep our costs low. The reason why is landfill, just when they receive the expanded polystyrene, they are paid per ton, and because of volume that use, they prefer to pay eco-captations to keep it ahead and didn't send it to the landfill. Just to show you a little bit where it's used, in that case, it's electrical substations. We feed like Hydro-Quebec, Hydro One, BC Hydro, almost all electrical company in Canada, also in United States. And with Hydro-Quebec, we have like a project to implement like a circularity inside the process. We use all their old packaging, just polystyrene packaging, and after that we built the product with that polystyrene, and we can ship back to Hydro-Quebec. Just it's a way just to show the circularity inside the product that Hydro-Quebec use. Just I have other projects, just the future development, as Eve talked previously. Just we work in partnership with the CDCQ, just to how we can revalorize the styrene and recycle MMA from windmill blades, from all the old bolts, all the with the pyrolysis. That's why we evaluate like how we can use the pyrolysis. Pyrolysis for old castle, it's something just can match pretty well in my sense. The reason why is because when we produce like with the windmill blades or the old boats, just we create like oil and we create the fiberglass. In my case, we use also we produce BMC. We talk another speaker talk about the SMC BMC. We produce BMC. We try that fiberglass inside our BMC. The fiberglass works pretty well. The mechanical properties, okay, it's a little bit lower, but not significant. That's why we know just we can really reuse the fiberglass in that way. And also from the oil, we can sort inside the oil. We have the styrene, and I already use styrene in my chemistry, and MMA also just, and we can reuse all these monomers inside my chemistry. Just and all the heavy oil, it's something the asphalt group can take care and use it for making asphalt. Just Oldcastle CRH is actually is one of the biggest recycler of asphalt in the world. That they reuse all the old asphalt and just put new oil inside, and we can reuse that flavor. And with the CDCQ, I work also just how revalorize and incorporate recycled component inside the SMC. Just it's another program, a Pratt program we use. We participate with the CDCQ. And that picture, it's a recycling glass company. Just we try to use the recycling glass as a filler instead of using sand inside the polymer concrete. And as someone says, just we should all time evaluate like what is the feedstock, if we have enough for our process before implementing production, because we cannot stop the production just because we're missing raw material or change all time our recipe because the feedstock it's not consistent. Just the consistency, it's the key on the recycling side. That's why we should evaluate properly. Thank you. Just if you have some questions after, we can talk about it.
Terrific. Thank you, Charles. Again, great presentation. Lots of interesting things going on at Oldcastle. I think you could have gone on a lot longer if you wanted to, because it sounds like there's lots of different initiatives. So yeah. I feel your pain as an R&D manager. Then, without further delay, just want to bring in Bill Santos. Bill is, as I mentioned, Director of Polyethylene Technology and Circular Polymers with Nova Chemicals. So he's going to speak to us today as the final panelist on flagship projects in Canada related to circular economy. And just a reminder for the group, so following Bill's presentation, we're going to go through a bit of a Q&A. So get your questions up on the board here so that we can challenge the panelists. Bill, over to you.
Hello, good afternoon for many. Still good morning here in the West. I hope you can hear me. the pleasure here today, following up on some great presentations so far in this panel 2 on circular economy projects. I feel like there's potentially a lot of synergy and alignment around some of the topics and the projects that are being undertaken here in a variety of different industries and areas of interest. Today, I'm going to talk about what we're doing at Nova Chemicals in terms of reshaping plastics. And before I get into that, just a little bit of an overview of who Nova Chemicals is. We do have a variety of employees across the globe, but we're mainly centered in Canada with a couple facilities in the US. The ones in Canada you may be familiar with, especially in southwestern Ontario, would be our facility in Sarnia, and actually our newest facility we just finished commissioning and operating our AST2, our Advanced Sclairtech polyethylene facility in the Corunna area. In Alberta, we also have polyethylene and ethylene facilities just about an hour and a half north of Calgary, where I'm calling in from today. And that basically highlights where we play. We produce ethylene and polyethylene for a variety of products, in particular food packaging. And I'll get into that in particular. So I get to the next slide. Trying to see if I can change the view here a little bit. Second. I'm letting me do these two views here for some odd reason.
We can see your slides, Bill, if that's the challenge.
Is you seeing the full slide though?
Yep.
Okay, you don't see like a block of black on the side?
Just down at the bottom, it looks like you can just toggle forward on that, but other than that, I think we're good to go. Okay,
great. So a little bit more around what we're doing in terms of circularity in the plastic production space. We're really focused on producing resins that can be part of the circular economy or circular packaging routes, whereby there are packaging solutions that are more easily recycled. We had a couple, a speaker here today speak around, plastics and waste getting into waterways or into landfills. Our focus in my department is really around how do we simplify plastic products and packaging so that they are recyclable, and really enhancing the recyclability of those different materials. So not only virgin plastics to be able to incorporate more virgin material, but also making material, as I said, easier to recycle, can put it into our blue bins and actually make it back into the loop versus going to waste. RPE supply and incorporation. One of the areas we're focusing on is actually just in the process of commissioning a mechanical recycling facility in Connorsville, Indiana. I didn't touch on that yet, and we'll get into a little more detail there. Really to start and really to grow that feedstock that's needed to support that recyclability. We're also continue discussions and policy around these aspects with various industry associations like the CIAC and the ACC and the US. And one of the areas I'll also touch on today is around how this is not a one company problem, an industry problem. It's really a societal challenge. And so I'll talk a little bit around what we're looking at trying to grow in terms of a center of excellence for plastic circularity. So as I mentioned, when we look at sustainability, we really have 4 pillars that we're looking at from a product recyclability and circular economy perspective. First and foremost, we need to keep the functionality. So, and what I mean by that is, regardless if it's a 100% recycled package, it needs to produce or perform like a original functional product. And we can do that, or are looking to do that, even by lightweighting, because in the end, if you have less material, again, it's going to be easier to keep it within the work stream. And if you can be more sustainable from a product production perspective and emissions perspective. Really, it focuses around design for circularity, the recyclability, but it's beyond even recyclability. We have reusability and durability, and I'll get into what I mean by that here in the upcoming slides. And really, it's around increasing recycled content of our products as they go into the various streams and markets, regardless if it's food packaging, construction, what have you. In the end, what we're really looking at is, I borrowed a quote here from Antoine de Saint-Exupéry from The Little Prince. We're actually looking at perfection is not around how much more to add, but we're at a time here where it's actually, how do you simplify and make designs easier? So there's really nothing more to take away, but you're actually enhancing the recyclability and sustainability of the product lines. Here are a couple examples you can see around what is actually involved, or the technology that's actually within a package. So everyone, very familiar, walk down your local grocery aisle, you'll see various cereals, different cartons or pouches containing various food packages. Very thin, micron to millimeter thick packages, but they are actually made up of 3, 5, 7, sometimes even 18 layers of material. What we're doing is, how do we take that complex design and make it monomaterial, or at least all with the same base material, which in this case for us is polyethylene. So this is where, on the right hand side, this is an example of a sort of mac and cheese pouch, where we've been able to replace, say, PET and adhesive layers to one that has still multi-layer, but they're all polyethylene based, or plastomer polyethylene based material, which again makes it easier to then be able to go through the loop in terms of recycling. But even beyond recycling, we look at also opportunities to think about upcycling as well. Products don't actually necessarily have to go back into the same application they came from. We need to be able to design with the end in life. So end of life in mind. So for example, we've been working with milk jugs and milk jug sort of feedstocks, and they actually go into a variety of uses. We've used them as an organization into our Syndigo packaging, which is our trade name for our recycled containing material that we've launched last year. But that same milk jug material can go into various containers. This looks like sort of engine oil container, into furniture like chairs, or even decking. We've also taken that same milk jug material and made are using them in applications for water bottle caps or sodas, where traditionally those caps on those bottles were actually made of polypropylene, so on a polyethylene bottle. So we've also been able to uniformly design an overall package, because in the end, now you have the same package for the bottle, or material for the bottle, as you have for the cap. So traditionally, that has been a challenge as well. So take a few minutes to talk about our first mechanical recycling facility, as I mentioned, in Indiana. Folks might wonder why Connorsville, Indiana. One of the reasons is that it's actually located strategically near 5 metropolitan areas, Indianapolis, Cincinnati, Columbus, Louisville, and Chicago. Because you need the breadth of feedstock to be able to, as I mentioned earlier, to be able to then bring it in and actually use that feedstock to make recycled content. So we're hoping actually to start up this facility here in January of 2025, where by 2026 we'll have the capability of recycling up to 110 million pounds of material, which then can be put into a variety of product streams, either as pure recycled material or incorporated into virgin material to increase recycled content. That is what consumers want. That's what brand owners want. And in the end, that's what we want as a society, to divert this material and actually reuse it versus going into landfills or other places in the environment. By having and including now a diversion of mechanical recycling, we actually now change the overall value chain for how plastics are produced and ultimately used from an end-of-life perspective. You could see here, traditionally, and it is still today, virgin plastics are formed either from gas feedstocks, which we use in Canada and at Nova, or naphtha from oil cuts. Ultimately go through the polymerization process, goes through packaging, which are the converters, then your retailers, where we all go and purchase these materials, and as I say, from the grocery store. Then there's end of life from a consumer perspective. Then it goes into the collection and sorting. We are now incorporating this mechanical recycling route, but we're also looking at advanced recycling. One of the challenges still, as much as we are focused on monomaterials and enhancing recyclability, there are always, or at least today, still plastics that won't be able to go into those streams. So how, from an advanced recycling perspective, can we ensure that we can recycle all plastics? And that is really the focus, or one of the focuses around the advancing, really an opportunity for Canada to advance some leadership in the circular economy. And we felt at Nova that there's an opportunity to create a hub where we could bring industry, government, and researchers together around the challenges regarding plastic circularity. And that what we've created earlier this year is this center of excellence around plastic circularity, really focused around mechanical recycling, which I talked about today, and elevating that performance and quality of the material that goes into the mechanical recycling streams. Advanced recycling, really looking at non-catalytic conversion of or thermal conversion of the recycled materials for those harder to recycle plastics, and also microplastics. One of the pieces, I think one of the previous speakers touched on this, Amanda, I believe. How do we ultimately are better at detecting and capturing microplastics that are in our water streams, and how could we end up using them? So it's really around these three main pillars in order to build the key infrastructure required to be able to deliver in these spaces, and first and foremost, the innovation for those ideas and technologies to help us advance circular packaging and circular technologies around recycling. And there's a third aspect, is around education and knowledge around informing consumers of their choices, and enhancing consistency across plastic waste streams. And we've been doing some of this today with our customers, our brand owner, value chain partners as well. And this is just a picture of some of the key pieces of equipment that we have within our research facility, our Center for Performance Applications here in Alberta, that actually produce a lot of these packaging products, either pouches or films, bottle caps, that can test and ensure that the performance and quality of these recycled materials actually perform the way you expect them to, depending on the application of choice. And I just wanted to end here to just around some of the various collaborations and partners that we continue to participate in, both in Canada and the US and globally. And some of these might be familiar organizations to you, be it the CIAC, the Alliance to End Plastic Waste, the Closed Loop Circular Plastics Fund, or more locally, the Canada's Plastics Pact. We need to continue to invest and participate in a variety of products, because I mentioned earlier, this is not an area that was going to be solved by one or two organizations. It's really going to take the efforts of many. And that's all I was going to say there today, and look forward to the questions during the panel session.
Terrific. Thank you, Bill. I have to say that's the first time I've seen a reference to Le Petit Prince during a technical presentation. So thank you for bringing that to our attention.
You're welcome.
So to the audience, that's the final one of our presentations, and thank you for the other. Well, thank you to all the presenters, of course, and thank you for coming on screen as well. So we have some time here to ask some questions of our presenters. I'm going to just kind of kick things off. There's a couple in the chat here, but I'm going to kick things off just real quick, and maybe to you, Amanda. When you talk about this fantastic product and clearly a market need, but I'm curious, as you go out to the market, what kind of reception are you getting to the product that you're developing?
Yeah, great question. Always excitement. One, like lack of awareness that there are other options needed, because people are seeing things like eco-friendly, biodegradable on their current packaging and options, things that are packaged in cardboard or have cues that something might be more sustainable or eco-friendly. There's a lot of confusion. When actually speaking with investors or potential pilot customers, the biggest question is one, cost. And right now, obviously, compared to a long-standing record of using virgin plastics or fossil-derived materials, where we're at cost-wise, to be able to scale that, like we really need these solutions to be adopted at mass to be able to scale those down. So there's optimism, there's interest, there's certainly more of an appetite for learning and understanding the solutions that exist. I think that there are so many complex problems that weave into this, that there's just such an unawareness of how everything is connected. So it's great to be able to start to have those conversations, and ultimately what we're hoping for is to keep refining what we have, but also not be reinventing the wheel. So if somebody else has a complementary technology, they can support us with packaging. There's an element we can use from somebody else's supply chain. We want to be able to pull those together so that we can ultimately scale these costs down and get them more widely adopted sooner than later.
Terrific. Thank you for that. And maybe over to you here for a moment, Ian, because it's a specific product that's being developed around modularity or modular homes. Maybe similar question. What are you seeing the market telling you about this solution that's being developed?
Well, right now we've mostly shown a few architects and a few developers There is the interest, but it's different from the workflow that they have right now. So there is going to be a ramp up on how this can be used and be developed. So that's why right now we're first starting with seeking a design patent so that it incorporates everything in there, including how this can be designed and worked within the market.
Great, thank you for that. And maybe now I'm going to, because there is some similarity between the work that Oldcastle and Charles described and the work that Nova's doing, because you both made reference to recycling of post-consumer waste, and of course then there's the natural problem of contamination and the let's call it the purity of the feedstock. And I wouldn't mind, Charles, maybe you kick us off. What would you say is the biggest hurdle in terms of getting purity in your recycled feedstock?
It's start at the beginning of the chain. Just instead of the recycle bin we all have in front of our house, we should sort and cost a lot. Just it's have like some deposit area, just and everyone can bring the material there. Just we reduce at 90%. We are 90% good in feedstock. And also it's on my side, I can use some impurity inside. I evaluate like I can be like at 95% purity, and that works because I use a robust system.
Okay, terrific. Bill, maybe you want to comment it, because it looks like you've got this massive facility coming here soon that's going to be consuming a lot of post-consumer waste. Can you talk to purity of the feedstock that you're going to be able to handle on that?
Sure, maybe a little clarification too. So we're starting off with that facility with post-industrial waste, which is, as you touched on, it's going to be an easier feed stream to use initially because it doesn't have or will not have the sort of range of contaminants or impurities that post-consumer will. That said, that is the ultimate direction, is to get into and use post-consumer waste as well. And that's where the challenges do lie. We designed a facility, it's really around the washing and cleaning of the feedstock to be able to then ultimately get into the variety of applications that we're interested in, including food contact. So I saw there was a question there in the chat around food contact, non-objection food contact PCR. And what that means for us is that we have been able to show that using, in this originally with the post-industrial feeds, that we create a recycled material that is that has been approved to have contact in food applications. So the recycled pouch that I showed there, the Syndigo, those types of applications, it is clean and has shown to be virgin-like from that respect.
Fantastic, excellent.
Jeff, can I add also?
Yeah, you can absolutely add.
Yeah,
absolutely.
Eco-captations also buy a robot with an optic lens. This is how we can sort all different polystyrene, because in my case, I cannot use with flame retardant inside, and one of his other customer he need with flame retardant. That's why this is how he can sort with flame retardant and without flame retardant. It's with the optic lens on the robot. And instead of have like a conveyors and remove, the robot pick what he want, not remove from the belt.
Excellent, amazing. Thank you for that. Maybe coming back to you, Amanda. So of course you've got I'll call it proof of concept, maybe a little bit more than that. But as you kind of think about scaling of the product, where are you looking at producing it?
That's a great question. What we would love is to continue to build in Canada, because ideally with these solutions, we want them to be able to be replicable around the world. But how do you create that localized supply chain like as you do? So for right now, because we're focused on a species of seaweed that grows abundantly here in Canada, have access to kind of all of those researchers and specialists that we've been looking at partnering with, and obviously access to a very large ocean coast. So initially right now, we want to be focused on finishing that build here. But ultimately, if there are policy changes elsewhere, we want to be looking at other places, potentially Europe. I spent quite a bit of time over there in the last year, just through my work with ocean startups in blue economy. I was in Barcelona for the Ocean Decade Conference, and they're building ecosystems and what's the word that I am looking for? There's an entire port dedicated to supporting like blue ocean tech startups. So they're really allowing you that space to be able to test and commercialize your solution. But yeah, we're open to a couple of things, but initially for right now, we want to continue to build and design around a Canadian model. And sargassum is a huge problem in the Caribbean and other parts. So ultimately, we want to be able to test with different species and see what we can end up replicating around the world.
Fantastic. Great. A question for all of you, but I'm going to start with Ian. So in your respective industries and talking about circularity, and because I think, Charles, you brought it up around intellectual property and protection. Ian, do you want to talk about kind of the work that you've done, maybe any challenges or what you're observing in the case of prior art in your space?
Well, in our space, especially in the commercial side, it's really adoption is the hardest part, and also what the previous panel has spoken about is it's really the cost or economic cost is the issue of adopting to these circular economies. There are products and services out there that can help industry to reduce their energy usage and GHGs, but it's again the cost associated to achieve that is what I see the biggest struggle right now, or the biggest hurdle.
Okay, terrific. Thanks. Charles, do you want to talk about IP protection and what you're actually seeing in the literature, and is it an active space or not?
Not really. A little
Okay.
bit on some product, but not a lot. Just
Okay. Okay. Bill, do you have a comment on it?
From an IP perspective, it's a wide ranging. It depends on the specific applications, but it is a burgeoning area. If you take, we've done a bit of a IP landscape of this space, and it makes sense. This is a societal challenge. So academia is focusing in the space, industry is focusing. So I will say that patents are definitely coming out at a faster rate today than they were, say, 10 years ago.
Terrific. Amanda, do you have a comment on this? Because you have quite a unique product. So I'm wondering, I'm assuming it's protected.
I will, yeah, so just high level, kind of where we started looking at what our patent viability might be as we started looking at what's happening in the med tech sector. There's obviously a lot happening over there with the use of alginates and wound dressings and kind of those non-woven fibers. A lot is still very much in the synthetic space. So like really continuing to try to own what we've got going on from a bio side, but also ways that we can optimize that process for use of less chemicals like throughout the supply chain. So some other things that we'll look to consider as we start to refine this initial version and continue going. Naturally for us as well, protecting brand, because we want to be a B2B2C model, and also with everything we've got from a brand marketing perspective, that's also certainly going to be part of it as well, which Lambton has been a great support on through the last year too.
Excellent. So I'm just going to go to the chat here. So Raldwin has indicated, and I think you can all see that, the reference to, and I wouldn't say Ghana is alone here as being one of the dump sites for many plastic materials. And I think there are other jurisdictions in the world that are overwhelmed with the amount of materials. And I've seen them in the case of single-use clothing almost, right? And they're all over the world. So maybe I'll just start with you, Bill, in terms of comments on how do we address that when it comes to circularity? I know what we're doing going forward, but how could we address what was been produced previously?
So I think that's a great question, and really comes back to sort of that last slide I had up. It's a broad, I think, partnership and collaboration that's required. So a couple institutions that are focused on so quote unquote dumping sites. I think originally one of the areas was focused with Southeast Asia is the Alliance to End Plastic Waste, really looking at helping, well, educating and helping various geographical locations where we see sort of active dumping, that how can we put in the infrastructure to help with collection, sorting, diversion of some of these waste streams getting into our waterways and oceans in particular. So that was one of the founding aspects of the Alliance to End Plastic Waste, along with Closed Loop Circular Fund. And even closer to home, we've also partnered with the Great Lakes Plastic Cleanup as well. Again, with that same mindset around how do you put in the right infrastructure to be able to stop or prevent, divert some of these wastes getting into areas of our environment that it really shouldn't be in.
Perfect. Thanks, Bill. Charles, do you have a comment on that?
No.
Okay. All right. All right. Amanda, you have to have a comment on this.
Yeah, I'm definitely interested from like a wash, sanitation, hygiene, from a product lens, and like what could be potentially created and replicated. That's definitely something that has come up more and more in conversation. Especially, I've been navigating kind of the Black entrepreneur ecosystem here. I'm part of the Nobellum accelerator, and we do have a lot of international entrepreneurs that are part of it. So there have been conversations between like businesses. So it's a great point to bring up, and definitely something to consider in the future.
Perfect. Thank you. Ian, anything you want to add there?
Nope, not that I.
Okay. All right. Okay. So we're getting to lightning round here. So we have about 3 or 4 minutes that we have left. And so I'm going to just ask one more question of all of you. And maybe you just comment on that. So when we think about when you think about integrating circular economy in your operations, and maybe you could just give us maybe 1 to 3 areas that you see as the largest roadblocks or challenges that you faced. I apologize, there seems to be a bit of background here, but hopefully you can hear me. Largest challenges that you faced in implementing circular economy in your operations. And maybe I'll start with you, Bill, if you don't mind.
Sure. I think it's a few ways I could maybe answer or focus on that question. But I guess one of the biggest challenges, and I think it'll be still continuing going forward, is really changing the way that we normally do things. So how that affects, say, from a Nova Chemicals perspective, is the way we normally produce packaging, for example, or different films. What does that look like? Because in the end, I mean, when you're bringing in different materials, they'll need to be modified different ways. So are we willing to invest in the infrastructure and the equipment required to be able to advance the circular economy? I think that'll be a challenge. How does that happen? Can that be done from an industry perspective on its own? Is there an opportunity for government to help with that enhanced conversion and change? And then also tied to that, another continuing challenge will be, how do we continue to grow the infrastructure to increase the feedstock reach and availability to do recycling. North America, we're only at 9%. 9% of all plastics are recycled. There's a huge opportunity there. So that is a big challenge going forward. And how do we bring the right people to the table and investment in order to increase that feedstock?
Great, thanks. Andrea or Kelly, hopefully you can find out where that background noise is coming from, and we can kind of eliminate
Yeah,
it
we
here
are
as we wrap up.
trying. I don't.
Okay.
Just a reminder, if you don't already, please put on your silent on your microphones.
Yep, great. Sounds like a pocket dial to me, but anyways. Charles, anything you want to add there in terms of challenges to implementing circularity?
Money is all time the challenges. Just it's build like all time the business case, make it work. Just it's probably the good thing on my side is the vision of CRH. It's they have a visions of sustainable idea and think outside the box and try to find other solutions. Just to promote all that kind of ideas, but probably just stay competitive. It's probably the key to make it work and make sure just we can pursue and continue in that direction. Just but like Bill said, it's just we have a lot of opportunities because we didn't recycle a lot of plastics. And probably I know like all the previous speakers talk about regulations. I don't think regulations will takes all time really long to coming, and we should have like a global regulations all across the world. If Canada have a small regulations, everyone will surround it and just yeah.
Thank you, Charles. That's excellent. Amanda?
Yeah, for us, it really started with like our values and alignment. So any suppliers that we're going to be working with, even as right now we're working in a contract manufacturer capacity, it is a lot more challenging for us to have control over those elements. The biggest thing I've encountered to date has been the selection of the right material for we have a no rinse shave gel. So that whole dilemma of do we use initially when I was being sold like PCR plastic and ocean-bound plastic as the only sustainable solution a couple of years ago, looking at things like glass or aluminum. So for us, we've gone the aluminum route just for like infinite recyclability, but then that brings up other questions as to the linings and all of the other components that you start to uncover also have plastics woven in. So just continuing to constantly educate ourselves, be really transparent about what it is that we want to achieve, and keep having those open conversations with suppliers. And then once we have control over our manufacturing process, finding opportunities to be able to upcycle those materials into other parts, collaborate with other businesses. But that's really the goal.
Terrific. Thank you, Amanda. Last word to you, Ian.
Yeah, so repeating what Charles says, of course, the monetary value and the return on investment is the biggest one. And what we do here is when we're working with any of our clients as well, is we look at their situation and understand where they can implement sustainability and educate them on what their return on investment is. It could be soft costs, it could be hard costs, but at least they're educated and understand where they can start and go. And these research projects that we have are great because it also allows our design team to understand what's possible and implement these use cases as we see fit and provide some real information.
Fantastic, Ian. And I just want to, I'm going to bring it to an end there. Still see some questions here. Thank you so much for the panelists. I'm so thrilled with the diversity of companies that were, and all of you that spoke today, because it really brought home that circularity isn't one sector wide, right? There's many solutions, there's many sectors, but there's still challenges. And so it obviously, and I like Bill's slide in terms of circularity demands collaboration. And so reach out, and hopefully today's session will help you in your own personal circularity journey. Thank you very much.
Thank you.
Thank you, Jeff.
Thank you,
Thanks.
Jeff.
Thank you, everyone.
Yes.
Thank you, Jeff.
And thank you, everyone, for all the presenters today. It really was a great panel, and as Jeff mentioned, it showcased, many different projects and initiatives across various sectors and applications. So appreciate you taking the time and everyone for providing such good, interesting questions. At this time, we're going to take another quick break. So we will join back at 1:45 for their last panel, which is focused on strategies for a sustainable circular economy at, as mentioned, 1:45 Eastern. So see you back in 15.
You mean 2?
2, sorry. That would actually, we are going to become back at 2. Thank you, Jeff, for clarifying.
All right.
Bye-bye. Hello, everyone, and welcome back for our last panel of the day. Our third panel is focused on strategies for a sustainable circular economy, and our moderator will be Matthew Slawinski. Matthew is currently the executive director of the Sarnia-Lambton Economic Partnership. He brings over 13 years of dedicated experience in economic development. Previously, he was the Vice President of Economic Development, where he advanced regional growth, notably through initiatives like the Sarnia-Lambton Hybrid Chemistry Cluster and Ontario Hydrogen Hub. He's helped to position the region on the global investment map. He is a graduate of the University of Western Ontario's Master of Public Administration program and the University of Guelph BCom. Matthew is also recognized as one of North America's top 50 economic developers by Consultant Connect. Welcome, Matthew.
Thank you very much, Andrea. And welcome everybody to our panel on strategies for a sustainable circular economy. The objective of this panel is to provide exploration of national strategies for building and sustaining a circular economy. And we'll be featuring insights from our wonderful group of industry experts on best practices, economic benefits, regulatory frameworks, and the role of cross-sector collaboration in advancing circular initiatives. We're joined here today by Paul Shorthouse, who's the Managing Director at Circular Economy Leadership Canada, by Wayne Madever, the Advisor and Portfolio Manager at Bioindustrial Innovation Canada, and by Kent Wooten, who's the Managing Circular Material Innovations and Manager of Circular Material Innovations and Product Stewardship with Canadian Tire Corporation and their family of companies. Before passing it off to the first of our speakers, I did want to take a moment to emphasize from my perspective with the Sarnia-Lambton Economic Partnership the need to be strategic in developing out the sustainable circular economy. If we look at Sarnia-Lambton, for example, where we've had a long established energy and chemistry cluster that's operated along a very linear value chain, there's been more than a decade's worth of work to integrate sustainable and circular economy opportunities into that value chain. And there's been some very major successes over that time. I believe it's the true success has come from the fact that there's been incremental and well-defined shifts in doing better with what we've always done well. And this is really truly driven by leaders who are driving these circular economy concepts. With that, I would like to introduce the first of those leaders for his discussion here today. Paul Shorthouse is one of Canada's leading experts in the emerging circular economy, providing solutions and engaging leaders who are working at the intersection of business innovation, public policy, economic development, and sustainability. For over a decade, this work has placed him at the forefront of the important transition that is underway towards a greener, more prosperous, low-carbon economy. Paul took on the role of Managing Director of Circular Economy Leadership Canada in 2021. And in this role, he has worked to create the knowledge, networks, and opportunities that accelerate circular innovation across Canada's economy. CELC provides thought leadership, technical expertise, and collaborative platforms for accelerating systems change and the transition to a low-carbon circular economy in Canada. Paul, if you could please lead us off.
Great, thanks for that introduction, Matthew, and the detailed bio. Can you hear me okay? Wonderful.
Yes, no problem at all.
Excellent. I will just share a few slides and start by saying thanks very much for inviting me to participate in this panel discussion today. And it's been interesting to listen in to some of the applied research opportunities that have been happening across this network here, and also some of the business leaders that presented in the last panel. A lot of great innovation happening in this space. I'm going to maybe take a step back a little bit as part of my opening for this discussion, to talk a bit about the strategies for a sustainable circular economy. Kicking things off with a bit around why should Canada care about the circular economy in the first place, and what's really driving the efforts and the investment and the activities that we're seeing across Canada right now in the circular economy, and speak a little bit to what strategies we're focused on at CELC to help advance a circular economy in Canada. So thanks again. I'm the managing director of CELC, and we've been working in this space now for a number of years. And through that work, we're sort of learning, what's really of interest to Canada in this space. And there's been a lot of research done and some insights that I'll share just briefly right now. And that's really touching on the fact that at the highest level, in the linear economy that we're currently in, we're seeing enormous lost economic opportunities from failing to recapture the value of our material resources. And the reality is Canada is very wasteful today. Based on research that was done, Canada is about 6% circular today, which means that we're losing an enormous amount of our resources and materials after only one use sometimes. And a lot of those materials still have value. We're throwing away for example, when we bring home bags of groceries, the amount of food waste we throw out is a 3-to-1 ratio. So we're losing a huge amount of value in just that one example. And circular economy brings sort of a model as a solution for addressing that. Work that was done by the expert panel on the circular economy in Canada showed that Canada can become more economically successful, environmentally sustainable, and socially equitable by embracing circular economy. And there's been work that's been done by groups like the National Zero Waste Council and others. One report sort of showed how circular strategies in just 15 areas and applied in 6 sectors could reduce waste by about 5 million tons per year, and 5 million tons of greenhouse gas emissions could be reduced while creating about 20,000 jobs. So there's big opportunity here for Canada. I think at the highest level, when we're talking about circular economy, we're talking about a system where materials never become waste, and that we are able to maximize those value from our resources, decouple economic activity from the consumption of finite resources, and think about circularity from the whole value chain, whether it's in redesign, around maintenance, around reuse, repair, refurbishment, remanufacturing, and recycling sort of at the end of that chain. And because of that, that full spectrum of opportunity, Accenture has pointed out, this is a multi-trillion-dollar global opportunity to recapture that value. But it also has a linkage to, broader environmental and socioeconomic benefits. So whether it's minimizing waste and pollution or reducing emissions, it's also, essential and an opportunity for, economic and employment opportunities. And from sort of the socioeconomic side, you can see how there's strong connections with many of the UN Sustainable Development Goals. And we know that circular strategies will be essential for meeting our climate or our net zero goals and opportunities, because it takes, that entire life cycle approach to a product, which includes, the upstream supply chain emissions, raw material emissions, the use phases, as well as the end of life treatment, which includes essentially the 45% of global greenhouse gas emissions that come from how products are manufactured and used. And we've seen that about 50% of our carbon emissions come from resource extraction and the processing of those resources. So an opportunity to apply circular strategies to tackle that, but also in the nature space. So we've seen from research that 90% of nature loss is a result of resource extraction and processing, and that we've seen that efforts in areas like food systems and agriculture, and in forestry management, and in fibers and textiles, and in buildings and construction are sort of key areas where we can apply circular strategies to actually reduce the impact on nature. lastly, just to say that we're seeing, the opportunity for businesses in this space from a cost savings perspective, from a diversification of revenues, from enhanced brand reputation, from more supply chain resilience. And we've heard a lot about the innovation that's happening in this space already. BDC put out a great article about why adopting circular economy approaches can help businesses reduce their environmental impact while also lowering costs. And there's also been work done by the Ellen MacArthur Foundation that shows that circular business models can actually reduce investment risk. Work that was done with 222 European companies across 14 different industries showed that the more circular a company is, the lower risk they had on default on debt, but also that they showed a higher level of risk-adjusted stock performance on European listed companies. So interesting to see why that was. Some of the thinking is that obviously they have more diverse innovation happening within some of their business models, but they're also looking how they can achieve a decoupling from resources, and the anticipation of sort of changing customer preferences and stricter regulations is driving some of that. So interested to see how that plays out in the Canadian landscape. What I can say is in terms of what's driving circular economy in Canada right now is a combination of, I would say, 5 factors. One is around information and awareness. So we're seeing a much greater level of awareness of what circular economy is and how it can be applied. It's actually achieved megatrend status recently. We're seeing a lot more case studies, examples of best practice that people can learn from and adopt those within their own businesses or within their own organizations. We're seeing standardization of how we talk about circular economy, what it means, the measurement frameworks, as well as sort of standardized definitions like ISO 59000 that just came out recently. The second area is around policy and regulation. So we're seeing a growing amount of support of policy and regulation in this space that's serving as sort of a critical enabler for driving more activities and investments in this area. And that can be global policy level efforts like the UN Plastics Treaty, or specific areas where we're seeing policy that is looking to think about embodied carbon within buildings or within products, as well as regulation like extended producer responsibility rolling out here in Canada across different provinces, and also certification and standards and things like environmental product declarations that are now being pointed to within policy. The third area is around the finance and investment sector themselves, and they're seeing circular economy as a critical enabler for many of the environmental, social, and governance factors that they're focused on as sustainable investments. We're seeing a wide variety of new financial instruments that have been developed recently to support circular economy, whether it's debt or project financing or green bonds or public and private equity investments. But we're also seeing taxonomies that are being developed in Europe and elsewhere globally that realize the environmental and social benefits that circular brings, and that's being built into these sustainable finance frameworks. And now we're starting to see more regulation in that space pointing to this, whether it's in the EU's Corporate Sustainability Reporting Directive and their new standard for reporting around circular economy, or even the linkages with TCFD and nature. So lots happening in the finance space. Collaboration is another key driver. And so we're seeing really interesting models of collaboration globally, whether it's groups like GACER or whether it's with the Global Plastic Pacts that we have a Canadian Plastic Pact here as well in Canada. There's the textiles consortiums, there's circular building coalitions. A lot of this is driving kind of and breaking down some of the silos that we've traditionally seen in the way industry or supply chains are structured, and building more collaboration to advance or accelerate circular economy. And there's also that linkage with equity and inclusion. And we've seen a recent global roadmap for an inclusive circular economy released by Chatham House. Interesting insights on that. And then the innovation space. So really innovation being core to transforming business practices and supply chains, but also with policy and other angles. And obviously we're learning a lot today about what's happening here, but there's ways to leverage applied research and knowledge bases ways to leverage sort of advanced digital and physical technologies as enablers, as well as bio-based materials, which we heard a bit about in the last session. And then, some really interesting research collaborations like Eureka, where Canada is co-hosting that with Germany this year, and it's focused on circular economy, and obviously the syndicate that we're part of for today's session. In Canada, seeing a lot happening, whether it's within industry and different sectors, like I mentioned earlier, plastics and textiles. There's work happening in the food space or with the finance sector. Within government, we're seeing strategic roadmaps. We're seeing the work of the Zero Plastics Waste Agenda in Canada, but we're also seeing right to repair and other areas of collaboration that are happening right down to the community level. So Circular Cities and Regions Initiative, which are 30 different cities across Canada developing their circular roadmaps. We've seen innovation happening in Guelph and now in other areas through the Circular Opportunities Innovation Launchpad. Quebec's been doing a lot with their living labs on food and construction, and a whole number of other examples that I can't even get into. But just to say, there's a lot of traction happening at many different levels and across different sectors. One thing that we worked on and launched last year was the Circular Economy Action Plan for Canada. That came out of the summit that we hosted in Toronto last June in 2023. And really it's focused on 5 critical enablers, those ones that I just talked about in terms of the drivers: information, collaboration, innovation, policy, investment. And it talks about sort of 30 priority actions we're focused on in the near term, which is really a guiding framework, not just for CELC, but for the Canadian, across the ecosystem in terms of how we can advance circular economy. So we're seeing that as a bit of a driver as well. And just lastly, in terms of what we're working on in this space to help enable the circular economy ecosystem. So we're a network of networks. We're an initiative of what was formerly known as the Natural Step Canada, now called Generate Canada. And we work to champion a national approach. We serve as a bridge to similar networks internationally. And we do deep dive work on the critical enablers for circular economy and in some deep dive sort of sectors. And we're made up of a diversity of over 65 partners, from large corporates and multinationals, like you see here, including Canadian Tire, who's part of our panel today, as well as academic and applied research partners like Lambton College, NGOs, think tanks, and others. And we also work with a number of international partners globally, and to act as, like I mentioned, a bit of a bridge to bring what's happening in Canada to the global stage, but also learn from international best practices and bring that to Canada. So a two-way sort of knowledge exchange. And where we're focused is in those 3 sort of columns here: the critical enablers around supportive policy, around information and knowledge sharing, and around the finance sector. And then we do deep dives in construction and real estate work with the value chain there, with in the agri-food sector, and in critical minerals and metals as it relates to the transition to a net zero economy. And then we do a lot of convening. So the Canadian Circular Economy Summit, we host knowledge series events, and we have an online community platform for our partners to share knowledge and develop sort of deeper relationships and partnership opportunities. I'll just touch briefly on 3 of our multi-stakeholder, multi-year initiatives that we have underway right now. The first one is our government-to-government policy incubator. So we are currently working with 3 federal departments, 3 provincial agencies, and 6 local governments across Canada, and a number of supporting partners. And the G2G incubator is essentially a platform for multi-level government collaboration and relationship building and sort of peer-to-peer knowledge exchange to support coordinated policy development related to circular economy in Canada. What we're focused on initially for the first year and a bit is developing scalable, standardized methodologies for quantifying the environmental and socioeconomic impact of circular economy at the local level and in targeted sort of sectors and supply chains. And we're also developing a national and subnational level indicator framework for measuring and tracking circular economy activities in Canada. So that's the G2G initiative. I mentioned how circular finance is such a critical piece. We've been working with a number of financial institutions in Canada, including major banks, investors, insurance companies, and others to better understand how to unlock capital to flow into circular economy business models, into projects, into infrastructure. What are the risks there? And also we've developed a guidance document for the finance sector in Canada to help support circular economy lending and investing. And then the third area is a deeper dive with our new construction innovation hub. And the hub is really a central point for coordination and knowledge sharing to accelerate the adoption of circular practices within the construction real estate sector in Canada. And that we have spokes of the hub that are essentially regional test beds where hub partners undertake on-the-ground research and demonstration projects and pilots to demonstrate circularity in practice and learn by doing. And then we take that information and the outcomes from the research and the pilots and the demonstrations and turn those into case studies and policy briefs to amplify that with key audiences to spiral sort of circular strategies over time into the construction sector. And we're just in the process of launching this new hub as we speak. And then lastly, I'll just reference the plans for our next Canadian Circular Economy Summit. I'll put the link to that in the chat box, but it'll bring close to 1,000 people together in Montreal this coming April 15th to 17th for very interactive programming and a real diversity of sort of who the key circular economy leaders and champions are from right across Canada in Montreal. So I definitely welcome people if they're interested in joining us for the summit. Be a rich dialogue and lots of opportunities for deeper relationship building. So I'll stop there, more on our website, and look forward to the questions and dialogue.
Thank you so much, Paul. It's great to see the excellent work that CLC is involved in and what you're working towards as an organization. Next, I'd like to bring in Wayne Madover. Wayne has held senior executive management positions with technically based businesses in startup, turnaround, or acquisition situations. His experience in both private and public companies, both domestically and internationally, spans a broad variety of industries, including bio and advanced materials, precision manufacturing, recycling, waste to energy, and medical devices. He's currently an advisor and portfolio manager at Bioindustrial Innovation Canada, while also lecturing at McMaster University on leadership for innovation. Wayne, the stage is all yours.
Great. Thank you very much. And hopefully we'll be able to share things successfully here. I'm hoping that everyone can see that in presentation mode. So, well, the old saying is if it was easy, everybody would be doing it. And so today I'm going to talk about some of the challenges I think are ahead to achieving the circular economy. And this is based both on my current efforts as portfolio manager for Bioindustrial Innovation Canada, but also as an operating leader in companies that have been involved in recycling and, without giving my age away, going back a number of decades. But a little bit about BIC. We are an accelerator. We operate nationally, and what we do is provide a number of things, strategic advice. We have some supporting grant programs. We deploy individuals from our organization, both operationally and technically, to help startups, and we make investments. We are a seed stage investor through our fund called the Sustainable Chemistry Alliance Fund. And those two words, sustainable chemistry, are the keys to our fund. Clearly, we are focused on carbon reduction, GHG reduction, and the circular economy is part of that. But clearly, there are overlaps between circular economy. There are subset, if you want, of our main target. So I'm going to. No, that's not changing. Is that changing for anyone? There we go. Thank you. Push the right button. So we are focused, no question, on non-renewable. Replacing non-renewable and fossil-based materials with bio-based materials in all aspects. We've had a pretty good track record. We've created about $25 million of direct investment. We've leveraged that with other parties because we are seed stage. So we want to get the companies to the Series A, Series B level of investment. We've created jobs, both directly and indirectly. A list of some of the companies you'll see there. I'm going to talk about a number of these specifically that are focused on the circular economy. We know that to date we've reduced over a megaton of CO2 emissions with the companies we deal with, because the studies that they do is part of, in particular, SDTC projects. When it comes to actual circular economy investments, I'm just going to categorize some of them we have. In the area of water, we have Greater, which is a gray water recycling system for domestic and industrial use, but particularly for domestic use. Forward Water Technologies, which deals with highly compromised industrial wastewater, but is now also involved in the lithium extraction process. Most of the world's lithium comes from brines, and I'll talk a little bit later about why that's circular, particularly in industrial settings. In terms of batteries and how they affect EVs, we have three companies. We have Green Graphite Technology, which is recycling graphite, which consists of it's about 45% of the weight of a battery. Life Cycle, which is one of the first lithium-ion battery recycling companies, went public on the New York Exchange at a $1.6 billion valuation a couple years ago. And Cyclic Materials, which is focused on rare earth recycling. In terms of materials, we have New Rubber Technologies, which is a rubber recycler, Green Mantra, which is a polymeric material recycler, and Life Cycle Health, what their goal is to collect, this started back in COVID, collect masks, gowns, and other materials like that, recycle them, the polyethylene and polypropylene that are in those materials, recycle them and create new non-woven materials. In biochemicals, we have Origin Materials, which uses bio-based materials to form a chemical intermediate, and Woodland Biofuels, who use biomass to create renewable fuels, hydrogen, renewable natural gas. Clearly, the circular bioeconomy is key to our operation and our whole thought process. We can talk about a number of areas where this affects the economy. Windows, we have companies that are looking at films for windows, heating, geothermal heating, things like this. Obviously, other people in this discussion have probably dealt with a lot of these matters. We were an early investor in a company called Ecosynthetics, which deals with adhesives and sealants. So many of the things that we see every day, there's no question they can be replaced in the long run with biomaterials, and that is one of the cores of the things that we do. Clearly, there's Canada has a huge resource in terms of biomass that we really are not using consistently. We're missing a massive opportunity. I know that expression's being used. Paul used it. I'm sure it was used earlier in this conference, but we really are missing a significant opportunity to use the biomass that we have. And this includes food, as we just heard, but also biofuels, biomass, to convert them into energy crops, things like that, and just residues that are left in the field after harvest that are just going to waste. So I want to talk a little bit about the headwinds and tailwinds in terms of achieving the circular economy, and I'm really throwing out ideas for thought as we move forward and try and move forward on a number of different levels. And these are really just discussions to get people thinking, hopefully. Those categories are really, what's the regulatory environment? What are the business economics? Are there geopolitical aspects to this? And are we doing proper cradle-to-grave analysis? Are we making decisions based on real data, or is it just an impression? And finally, something near and dear to our hearts, which is early-stage funding. How do we get the technologies that we need to achieve the circular economy? How do we get those companies going? So, regulatory environments, they're out there. There's no question. California has had recycling for plastic bags. Again, I'm going to date myself, but I ran a company called Resource Plastics back in the 90s in Canada. It was Canada's largest post-consumer recycler at that time. And One of the things that helped us was that at that time, California brought in legislation saying that trash bags had to have 10% weight of post-consumer material. So even though we were in Brantford, Ontario, we were shipping material to California to meet that regulation. And they've got further regulations now that's continued to grow. Greater, which is a gray water recycling company for domestic use, states are starting to realize that there's a rationale to do this. They're running short of water. If you think about Arizona, Colorado, places like that, how do we incent both home builders and homeowners to put these systems in place? Because frankly, what they're doing is they're collecting the shower water, cleaning it up, and putting it in the toilet. In most homes, those volumes, which are about 25% of the water used, those are balanced. Zero liquid discharge in Europe. Any kind of processed water used in a chemical process, it's important that in the new European regulations, that doesn't go down the drain. It gets reused. And forward water, which is a forward osmosis process, has a methodology of doing that. This is very interesting, I think. Sweden, and we always think, of course, of Europe and particularly Scandinavian countries as being ahead of us. They've started to put roadmaps in place. But what's important here is that it's the industries themselves that have produced these roadmaps and collaborating with the government. It's not just the government saying, here's what you will do. The industries have produced these roadmaps, 22 different industries. And so there's a very united front there that I think we need to consider of how we move forward. Business and market economics, they're great ideas, but let's be honest, economics drive businesses. Drop in EV sales right now has driven the price for lithium down. So does that affect lithium-ion battery recyclers? Why are those sales down? Well, EV cost, performance, but there's no question that market, what's happening in that market affects recycling in our circular economy. Similar with gray water, it makes sense to do it. Water restrictions in states in the Southwest US. However, is it too expensive for a home builder to include it in the home, to even include the piping to do gray water? Now, some jurisdictions are now saying, if you're building a new home, you have to at least do the plumbing to facilitate gray water collection in the future. However, the flip side of this coin is there are certain areas, including even Sarnia, where Matthew is, where some industries are getting their water for processed water from wells, and they are restricted in terms of their production because they can only get so much water. It's easy for us in the Great Lakes area to think about those big blue bodies of water around us and think that water is infinitely available, but it's not the case. And so in those cases, it may be the economics of simply recovering some of that water, recycling and recovering it, that can drive that business, affect their economics, and therefore move the needle in the circular economy. But there is a challenge if there's no regulatory framework. Some of these companies are affected by commodity prices. So high prices in a commodity, and those could be any commodities you can think of, metals, materials, polymers, they encourage the use of recycled material. However, low prices in commodities go up and down, discourage the use, because typically there is a difference in the virgin material and the recycled material in terms of processing and physical properties. We're starting to see, particularly in Europe, there's no green premium anymore. And while early entries can establish a market for circular products, often they're victims to the commodity prices. But fortunately, second generation technologies generally have lower costs and are more resistant to market shifts. Now, all this requires investment, which is something I'm going to get to a little later in this discussion. I just want to show you an example, and unfortunately, I've got the scars on my back from both of these. One of them was Resource Plastics, which I mentioned was the Canada's largest post-consumer recycler, which I stepped in as CEO after it came out of bankruptcy protection. We got the company running on an economic basis where we were covering our costs, and we had no problem finding customers. The challenge was getting the operations to the point where we're producing enough material to cover costs, which we did. However, polyethylene is a commodity, and as commodities happen, suddenly the price of polyethylene dropped suddenly because a number of major polyethylene plants, Dow, Nova, people like that, came on stream. The price drops. And just to give you an idea of sort of magnitude here, we were selling our material between 70 and 80 cents a pound when polyethylene was $1.20. When polyethylene dropped to 90 cents to $1, the simple fact was our sales dropped in half within about 60 days because it was not worth the effort to the extra processing care and the reduced physical properties of a recycled material. The same thing happened with rubber pricing. I was involved with a British company that had operations in Canada and in Berlin to recycle rubber. This was driven after the financial crisis. The price of natural rubber soared. Chinese and Indian economies were taking off. And our premise there was to take scrap from molding of rubber, which is vulcanized, cross-linked, de-vulcanize it, and send it back to the originator, a toll processing model, if you want. Everything was great until all of a sudden the price of rubber started to fall. And once it fell to a certain level, even though rubber produces about 30% scrap in the operation when you're molding rubber, it simply did not, there was not enough of an economic benefit to overcome the difference in physical properties of a recycled material and the virgin material. So just two examples of how commodity prices can affect the economics of these companies. Both of those cases were early stage companies. I mean, there's no question today that plastic recycling takes place because the technologies have improved and are at lower cost. But another strategy to do this is upcycle. So new rubber technologies. In fact, the patent they used was from Watson Brown. I happened to sell it to New Rubber long before I joined BIC. They create new products from recycled tires. They're not just making mulch and playing field rubber. They're actually making very interesting upcycle products like floor mats and geotextiles. Green Mantra similarly takes scrap polypropylene, they depolymerize it into a very narrow molecular weight range, and it becomes a functional wax. And now that is being used. The major customer is, this is a multi-million-dollar revenue company now. Their major customer is in shingles, replacing bitumen, but it actually provides better performance for the shingles, better low temperature properties in terms of hail damage and things like that. And it can also act as a processing aid to up the wood content in wood plastic composites. So there are ways to overcome those business economics. Geopolitical effects. 100% of the world's graphite for batteries comes from China. It may not all be mined there, but the processing occurs there. And it's about 45 to 50% of a battery mass. Same with rare earths coming from China and cobalt from the Congo. So what happens with the supply chain curve changes? I was involved with solar silicon many years ago when the silicon took off for solar silicon. And it was $1.20 a pound on the or a kilogram on the spot market. And so the number of companies, I was involved with a pioneer company to actually make lower cost solar silicon. Everything was great. The price starts to drop. Now the price for the spot price for solar silicon is probably in the teens. So everybody jumps on the bandwagon, and unfortunately, the early adopters tend to be the ones that drop off. Are we making the right decisions? And I'm going to keep moving forward here because I see my time is moving on. When I walked into Home Depot the other day, there was a paper bag there. And I heard from the Ontario government that they've reinitiated paper bags at the LCBO because somebody doesn't want anyone showing that they're carrying a bottle. Well, are we really doing the right thing for the environment using paper? It really comes down to modifying consumer behavior. I think we've achieved that largely in grocery shopping. We're not worried about paper versus plastic anymore. People are bringing their own bags home. And that's got to be a massive part of moving the country, moving society to a circular economy, is modifying consumer behavior. We have heard for decades about being a disposable economy. And that's what we really need to do. I think it's pretty much happened in grocery. You see people walk in with their bags because the others aren't available. So you have to do something. EVs, are we doing the right things there? We have laws that are going to ban the sale in Canada of petrol-powered vehicles by 2035. Do we have the technology? Is it ready? Will it be there? I mean, there's no question there's cause effect here, but we need to think about these things. Would we be better off with hybrids and renewable fuels, setting targets that are achievable? Let's face it, Ontario's an oddball. We have most of our power is non-thermal, but that's not the case in the rest of the world. They're not really zero emission vehicles in most of the world. They just move the emissions somewhere else. And we're decades away from moving this pie chart to being more renewable. So I'm going to finish now with early stage funding. I mean, this is one of the problems we have. We see it. We're a seed stage investor. And I can tell you right now that many funders in the venture capital community are moving away from seed stage and going to growth mode. And I can be somewhat cynical and say, well, that's a lot easier at that stage when companies are gaining traction. And as an investor, there's no question it's a lower risk investment. But if we don't invest in seed stage companies, there will be no pipeline for growth investment. There will not be those second and third stage technologies that will move us to the circular economy. So what can we do? Well, legislation does kickstart an industry. Look at the blue box. Before the blue box, I was working on degradable plastics in the early 80s. There was no recycling. All of a sudden, the blue box comes along. There is a recycling industry. The inclusion of biofuels into petrol fuels that we have every time we fill up our cars. It can be done, but we need to do with cradle-to-grave analysis and achievable stage targets to move us to the end zone. And no question, we need to create behavioral changes overtly or covertly. And so finally, what could we do? Well, look at direct government funding, focusing on seed stage. We need to see more of that, not moving away from it. Indirect government funding, the labor-sponsored venture funds that were so popular a few years ago, we could increase the deduction for the average taxpayer who wants to invest in this, the number of dollars per year and the percentage tax credit. Many of you may not even know that investment option is open to you. And the mining industry for many years, Canada, here we are, a hewer of trees and a breaker of rocks, have had flow-through shares where investors can get 100% tax deduction for the amount they invest in the shares, plus a tax credit. And of course, if the investment grows, then it's a successful mission all around. So there are things we can do, both driving private and government investors to feed the seed stage, the early stage companies, but the government can also do something in terms of funding through individuals and just broaden the base of investment for those early stage companies. So I think I'm just about at my time limit. Obviously, we'll have some questions later and hopefully some food for thought there. Thank you.
Wayne, it's always a pleasure to learn from your experience and certainly hear your insight. Before moving to our next speaker, I'd like to encourage the audience certainly to populate the chat or the Q&A with any questions you might have for our panelists. There's a wealth of expertise here at hand who would be more than willing to answer any questions you may have. With that said, I'd now like to bring in Kent Wooten. Kent is a sustainability professional with over a decade of experience in developing and managing sustainable and environmental strategies. He's currently the manager of circular materials innovation for Canadian Tire, and he's responsible for driving the implementation and integration of circular economy partnerships and implementing sustainable product packaging improvements across the Canadian Tire family of companies. Kent plays an important role in making life in Canada better by being a part of the solution to reduce landfill waste and by driving circular economy opportunities. The floor is yours, Kent.
Hi, thank you. Thank you for having me today here. I'm just going to get my presentation lined up. Just take me a second. Okay. Yeah, there's a lot more to Canadian Tire than most people understand. Like, we own a lot of companies and we own 110 different brands. So that makes we can have a big impact in the market. I'm just going to name a few of the companies to start with. Mark, Sport Check, Atmosphere, Nevada Bob Golf. We own a bank, we own gas stations. So we have, and then 110 different brands. And a few I'll just mention that you may not know: Raleigh Bikes, Sherwood Hockey, Nova, Dakota, Denver Haynes, Nova Lights. You know, those are more the popular ones. But we have many, Motormaster, Maximum Tools, and we cover every product category and every type of packaging. And a big part of my job is to identify the challenges we have with our packaging to help expand the recycling in the Canadian market by moving to monomaterial, eliminating contaminants. You know, we're doing our part to include recycled content where we can. You know, I've been with Canadian Tire for 14 years. I'm on my third position in the company, and they've all been great experiences. It's You know, I'm also the co-chair of the Canada Plastic Pact Recycling Working Group to advance recycled content in the Canadian market. Paul mentioned I'm also a member of Paul's group. You know, we're a member of multiple different groups in the industry. We're trying to make a difference. I think we are. You know, like, we're not just talking about it, we're doing it. And I think that's the fundamental difference. And I'll talk about producer responsibility later on. You know, and a big part of my responsibility is the federal plastic registry, and federal government and provincial government, and I'll expand on it. The trending, you got to take action now. You know where it's going. People that take action now are going to be successful, and that's the bottom line. You know, the Canada Plastic Pact reporting as a volunteer. Well, we volunteered to join that group. And we do the reporting, you know, and I'll move on here. You know, the big part of ours is communication with the vendors that make our brands. We don't have factories that make stuff, but we reach out and partner with other companies that make our products. And we've created and shared with every company in the world that makes our brands sustainable packaging standards. We're letting them know that we're on this journey and what our expectations are. You know, we're looking to move to recycled material, include recycled content in our packaging and our products, eliminate hard to recycled material. Our standards, and I'll share it with anybody who wants, because I've shared it with all over the world already. It's not like a secret. So basically, we're looking to eliminate PVC, polystyrene, PETG, mixed plastics, bioplastics. In our opinion, they're contaminants. And by eliminating contaminants and moving where we can to monomaterial, we're going to help advance recycling in the Canadian market. Because right now, the Canadian market is based on, you know, mechanical recycling. I know there's chemical recycling down the road, but it's not here yet. So we're taking action based on the current industry capabilities and trying to help industry and to help the Canadian environment as a whole. And we believe that we're aligning with generally accepted industry practices. And I say that because the problematic plastics, they were discussed in the Canada Plastic Pact, and the members of the Canada Plastic Pact are throughout the whole value chain. And that's important because you got brand owners, resin suppliers, manufacturers, all together, packaging companies, and we're all collaborating. You know, and I'll talk about a few of the partnerships that we've already had as a result of that, being a member of the Canada Plastic Pact, and also Paul's group, the Circular Economy Leadership Group. I have 3 examples here, and I'll start with the first on the left. We're partnering with Canadian companies to advance the circular economy where possible. You know, here's 2 companies that we partnered with, Ice Rivers and Multi-Home. They're both Canadian companies. The vases on the left are made by Multi-Home. They contain recycled tires sourced from our garages. So they're a great example, 100% recycled content. The chair on the right is made from 230,000, or no, sorry, I stand corrected, 34,000 pop bottle lids. So they didn't go to landfill. They're a chair, and that's under our Canvas brand, both products. So this is a great example of partnerships. All three companies are members of the Canada Plastic Pact. So it shows that the collaboration, it's working. You know, because I heard one announcer say before today, it's not one company that can make the difference. It has to be a collaboration. And although Canadian Tire is kind of a big company, we can't do it ourselves. We have to reach out, partner with other people, and to make it happen. This is just two examples of many examples we have already. We haven't told our story well enough yet, but we will. We've already launched our second ESG report. I encourage you to look at it. It's awesome. It documents our commitment, what we're doing from a wide scope of topics. The picture in the middle here is a recent project, and it's a partnership that we went through the Canada Plastic Pact again with EcoTank. It's a window washer dispenser with no plastic jug. We started out with 25 units at our gas stations, mostly on the en route centers because of the high traffic. So consider this, we haven't marketed yet. We've already saved, and it's summertime, so usually people buy a window washer when the weather is bad. We've saved over 8,000 jugs so far. That's a great start. We've just recently expanded to 50 units, 2 in Quebec and the rest in Ontario. And we're planning and we're looking at expanding into BC. So this is a great example of what can be achieved. You know, once we get 50 units online on our en route centers, start marketing behind it, and we get bad weather, the number of plastic jugs that are going to be eliminated from the market is going to go really high up. So this is a huge victory. I'll be speaking about this partnership at the upcoming next week Montreal event, so that'll be great. We're also looking at our current business operations. The picture on the right is a picture of the vice president and AVP of Party City with our team in product stewardship and Jim from PAC Global doing a store walk. We're looking to identify opportunities at Party City because we own it in terms of improving the packaging, moving away from single-use packaging. And on the note of single-use packaging, the federal government, you know how they had the appeal, it's kind of on hold right now. We're taking action now as if it's a go. You know, and I think that's a positive sense. We know it's going to come. We know it's the right thing to do. So we're taking action as if it's a go already. And I think that's a positive attitude that I'm proud of. And this is just to name a few of the initiatives that we have. You know, like we have Mark's shirts, we own Mark's, made from plastic bottles. So another great initiative. Helly Hansen uses a lot of recycled content in their clothing. We own Helly Hansen too. So it's kind of convenient. But the amount of recycled content that we're already using is far more than people understand. And so we're actively looking to make partnerships in the market, not only with manufacturers, but resin suppliers. And I think that's positive. And a big part of that is taking part in these industry groups and discussing things, you know, and looking for partnership opportunity, new innovations. You know, I mentioned the federal government. Okay, like you have the plastic registry. That's huge by itself. Okay, and as a brand owner of so many brands, it has a big impact on us. And I'm responsible for it, so I got to figure it out. And to say it's complex would be an understatement, because here's how it's expanding. It's not only the plastic in our packaging, but they want to know about the plastics in the products, the components. Okay, the drill comes in a plastic case, but then the drill is made of plastic, the shell, but what's inside of it? What type of plastic? What's the electrical plug made out of? You know, they want to know immense detail. So that's the trending. The federal government also has some draft regulations on labeling of recycled content. That matters. They also have another draft regulation that's coming down the pipe that recycled content minimums in certain product categories like garbage bags. I totally agree with it. It's going to the landfill, so why wouldn't it have recycled content? So I've already called our vendors that make our brands. We own Frank, and Frank's garbage bags or Simplicity, another one of our brands. They have garbage bags. And I said, hey, are you prepared for this? Do you have recycled content? And do you need me to hook you up with somebody? Because it's important. The law hasn't been finalized yet, but we know it's coming. So by taking proactive steps, it's going to make the world a difference. And making sure the partners that we're partnering with are informed and prepared. And with the recycled content, it's based on a scale. Like, okay, the first year they want so much, 2 years from now they want a lot more. So it's coming. The writing's on the wall. The provincial government, okay, that's a challenge by itself, and I'll tell you why. The harmonization, when you're a company and you sell products Canada-wide, okay, you got one product number, one product go, Canada. But you got provincial requirements, like Ontario is accepted the producer responsibility. And that's going to be a trend. It's basic. I'll sum up 40 pages of government. Government saying, we're no longer involved. We're not going to pay for recycling. You, the brand owner, figure it out, manage it, pay for it, your responsibility. That's really the gist of it. And we're okay with that because we're a reputable company. We're going to take responsibility and actions to manage the waste at the end of the life. But it's expensive. And, Alberta's already coming down next. And other provinces, it's going to be the trend. It's a cost savings for the government. As when you make a brand owner responsible, they're going to look at innovation. They're going to look at how can you do better, because they're paying for it. So you're all in. So you got to make it work, and you got to try to minimize the cost, because the end of life, I'll give you an example. I also oversee tire recycling in Ontario. We recycle just short of 600,000 tires a year. Not one of those tires goes to a landfill. It's recycled. And then I follow the trail. Who's buying that rubber? What are they making? Can we sell it? And that's a big part of my job. So that's a cool part, because when you see the second life for the product, and we try to up recycle, whenever we can, but recycling's recycling, not going to the landfill. That's awesome. The terms of producer responsibility. Basically, if you're the brand owner, you're it. Also, if you're the first importer, there's a little chart that you have to follow to figure out if you're responsible. But it is the trend. Other provinces are going to do it. Europe's already doing it. The US, I think they have 4 to 5 states that are looking into it and starting it. But in Canada, recycling is the way to go. And, like a big part of my job is to look for opportunities, partnerships, who's doing what, who has what. Like the example I mentioned, the company making our garbage bags. By reaching out to them, if they had said to me, you know what? Yeah, I hear you, but I don't, where am I going to get the recycled content? A big part of my job is grouping people together, communication, collaboration. And that's the way to do it. It's really the only way we're going to make a big difference in the market. So in saying everything, Canadian Tires, like we have in our ESG report, making life in Canada better. And it's just not a statement that, we put up and it's like a nice banner. We're actually taking action. We're doing it. We're making it happen. We got to get better at telling our story of everything that we're doing. I get it. And that's a big part of my responsibility. But we're a modest company that have always done the right thing when people aren't looking. And it makes me really proud to work at Canadian Tire. And thank you.
Thank you very much, Kent. I was looking forward to your presentation. It's great to see everything that Canadian Tire is pushing forward. Clearly clearly a leader across Canada. Right now, I guess I'd like to go through a set of questions with each of you, and as well as get to the question in the chat. While we do have a couple of minutes, perhaps I'll start with Paul. In terms of policy, where do you see the biggest barriers, and what are some immediate steps that government and regulatory bodies could take to overcome these?
Good question. I think some of the biggest challenges maybe around the policy side is just understanding how to design effective policy that supports the circular economy when you're still in a linear system. And so, some of the things that were mentioned earlier by other panel members on this session, are about the unintended consequences that might come from designing a well-intentioned policy, but it having kind of a negative impact, to what you wanted to do. So the example of, plastic bags and switching out to paper bags doesn't necessarily always bring an environmental benefit the way you want if you start thinking about water use or carbon emissions or other things. So there's that angle around designing smart policy that can help support, and not create the unintended consequences by error. So there's a lot that goes on to designing smart policy and engaging industry and others in that process. I think the other is around the multi-levels of government that we have in Canada, whether it's local, provincial, and federal, and how they both collaborate, but also how they harmonize efforts in that space so that you don't have a patchwork of policies that are driving costs up for industry, or confusion within the market, or having brands or companies having to redesign their packaging and that just to fit a small population in one part of the country. So there's that aspect, I think, that's really critical too, around harmonization of policy. And the third may be just around that geopolitical comment that was made earlier, around a key factor, certainly seeing what came out of the elections last night south of the border. How do we think about the opportunities for circular economy in this space? Think about our trade and policies, but where circular economy might be able to support resilience in supply chains, where we might take advantage of our biomass, bioeconomy opportunities. How does that sort of link into the geopolitical trends that are happening in that space, and how do we create policy that supports Canadian industry with circular strategies, but doesn't put added risk maybe and cost on industry.
Oh, perfect. Thank you so much for that in-depth comment. Perhaps what I'll do is shift into one of the items in the chat here, and I'll direct it at you, Wayne, if I may. It's asked, the economic development potential within the circular economy is tremendous, but it's not clear to the commenter that economic development agencies, whether they be federal, provincial, local, are focused on fostering circularity. Would you be able to provide a comment or observation on this, recognizing, of course, the role of Bioindustrial Innovation Canada, both at the local, provincial, and federal levels?
Well, I think there's an element of it. My point today is that it needs to be more collaborative between the different levels and deal with the realities. That's why I brought up the the paper bag versus plastic bag situation. We went skiing in BC just after the federal government talked about banning single-use plastics. Do I think that's a good thing? Absolutely. However, as I went to the grocery store, there were all the paper bags. Are we really doing the right thing for carbon emissions? And that's what we're driven by, as I said earlier, circular economy being a subset of that. So all I'm saying is we're going to have first of all, we need better collaboration, and we need it based on the science and the impacts. Give you another example. There's a lot of effort going into bioplastics, which is great. Using food waste, for example, to make PHA, PVA, things like that. Question that came to me back when I was doing degradable plastics out of starch, again, back in the 80s, from the fellow that founded Resource Plastics, long before I ended up being CEO, there was, well, what happens if some of that stuff gets into my recycling stream? So there's just a need for collaboration. We're early days in this, and it's a bit of a organized chaos. People looking for different business opportunities, all of whom have the same goal: to reduce carbon footprint. But we need to understand, if someone comes up with a bioplastic, and we're doing all this great work to recycle plastic, and some of that gets into the stream, does that affect it? I don't have the answer to that, but I think it needs to be considered. And so that's where we need some sort of collaborative effort to really say, are we trying to foster industries on one hand that may affect another circular economy industry on the other hand?
Excellent. Thank you so much for that comment, and recognizing that it was based around the question of both the all of the federal, provincial, local levels, and the collaboration amongst them. We often don't hear the discussion on the provincial level, and that was something, Kent, that you brought up and discussed to a certain extent. I'd like to ask you, from your perspective, looking across Canada, is there a province that you see as being ahead in driving circular economy concepts, where perhaps other provinces can try and emulate what that particular province is doing?
Yeah, I'd say Ontario right now, and the main reason for that in Ontario is because producer responsibility is already here. It started with tires, it moved on to other material, but now the entire Blue Box operation has just gone to producer responsibility. That means the brand owners are responsible. So we're now looking at it even closer to minimize the cost associated with that. Paul, you have a question?
No, I was going to add to the two questions actually that were there.
Yeah. Okay. Well, it's like we're looking Canada-wide. That's our scope, right? But I only mention Ontario first, is because financially, that's the biggest impact to us right now. And the government was right to say, if you make brand owners financially responsible, they're going to take initiative. They're going to look at it as a business. How do you do it cost effectively? We're not a charity. We're looking for, we're trying to make a living here. So it's a different mindset. It's in other provinces, it's a government program. You kind of go, and if they're not run efficiently or they're not making money, well, does it really impact you to the same degree? It doesn't.
Okay. No, thank you for that comment. Perhaps we'll pass over to Paul. I know you're looking to jump in.
Yeah, maybe I'll just make two comments. One around the economic development question, and that's I think we are seeing interest at the local level more so maybe than provincially across the board in Canada, but lots of interest at the local government with cities and their economic development agencies looking at how they can support local businesses. But we are seeing some of the regional economic development agencies like Pacifican and FedDev in Ontario that have supported circular economy initiatives like the Project Zero Accelerator out in BC and COIL in Ontario. But I think there's opportunities to do more of that. And I think because some of the benefits are recognized on the ground, it's sort of a bottom up in terms of the economic development interests kind of at the local, then up to the provincial and eventually, federal side of things. So opportunities to do more, I think, across provinces. And then secondly, on the leading provincial space, Quebec is certainly also another one that comes to mind. They have developed a number of roadmaps, both provincially and at the local level with City of Montreal and other cities to build circular economy into their policy frameworks and work really closely both with industry and sort of the applied research, academic side of things to look at circularity practices. But the language barrier and translation is sometimes a challenge to get that information out of Quebec and share it with the rest of Canada. So trying to work a little bit with the Quebec partners of ours to support on translating some of their learnings and best practices.
Okay, thank you, Paul. And recognizing we're starting to run short on time here, I see Kent has his hand up, so I'd like to give the opportunity for a closing comment there.
Yeah, I just want to say that keep in mind, like when I mentioned, if we make a product, it's Canada-wide, right? So if we implement sustainable packaging, recycled content, eliminate multiple materials, it benefits all provinces. So that's really an important element to understand.
Excellent. Thank you very much. And Wayne, your hands there. I wouldn't want to rid you of the opportunity.
So very, very quickly, I think the producer responsibility is key. And let's look at two examples. Automobile recycling in Europe, and that was being driven by lighter weight materials. BMW decided to make a polymeric intake manifold to save weight. Well, under the current policies in Europe, they have to have a way to recycle that material. And we can go back a number of decades again to emissions controls. Does government innovation work? Absolutely. In the 70s, gas shortages in the US, emission controls, the auto industries initially said, oh, it'll never work, et cetera, et cetera. They resisted. Now it's part of every car we drive. And in fact, we drive cars that are far, far more efficient and emit less. Small engines that produce the same power as those land yachts of the 60s and 70s. So it can work. There's no question.
Oh, excellent. Thank you very much for the nice discussion back and forth, especially here. In closing this panel, I'd really like to thank each of you, Paul, Wayne, Kent, for providing your insights and expertise in this enlightening discussion. You're all experts in your field. The importance of continued circular economy innovation across industries is crystal clear, and it needs to be associated with clear and well-developed and well-supported strategies. Clearly, from this discussion, this will be impacted by regulatory frameworks, finance availability, collaboration, geopolitics, and a variety of other external forces. With all of that said, I would like to pass it back to Andrea Hands for the closing of the summit.
Thank you, Matthew, and thank you to all of our panel 3 presentations. Very interesting topic, and I think we could go on for hours about it. So thank you for answering the questions. And for everyone, we've had such a great attendance today. It's great to see. As we come to the end of today's Circular Innovation Forum, we've learned lots about, different projects, had a very inspiring day, and each of our panels today have showcased not only success stories, I think, but also actionable strategies that we can demonstrate the potential to have a truly sustainable circular economy. We hope these insights inspire you to think about how your work in whatever sector you're in or you represent can play a role in advancing circular practices. On behalf of the Canadian Materials Circular Economy Syndicate, I'd like to thank the Circular Economy Leadership Canada for their support today, and I truly encourage everyone to check out their event. And I saw that Paul had shared the link to that event in the chat that's taking place in April in Montreal. I would like to thank, of course, all of our moderators today and our panelists who have provided their insights and expertise. Let's carry forward the ideas shared today, and let's be prepared for what comes next in our journey to work towards a thriving circular economy. Thank you all for attending, and I hope you enjoy the rest of your Wednesday.
Thanks, everyone.